Welcome back. In this video, we're going to see different ways to make pivot tables. If you're an Excel user, probably you made many pivot tables in the past. In Pandas, we can also make pivot tables. And in this case, we use two different methods, the pivot method and the pivot_table method. In this video, we're going to see the difference between the two of them. So, first, let's see what's the pivot method. So the pivot method reshapes data based on columns values, and it doesn't support data aggregation. So this means that this is not the regular pivot table you will see in Excel, because you can only reshape data with the pivot method, and you cannot do anything else. To explain you better what the pivot method does, I'm going to show you an example. So here we have a little data frame, and this one has 6 rows and 4 columns. And as you can see here, there are many duplicate values. For example, in the column foo, the 1 value is repeated at least twice, and the same goes for the 2 value. Also, in the column bar, you can see that the A, B, and C is duplicated. So when we have this type of data frame, we can reshape it to have a different view and to make a better analysis. In this case, we can use the pivot method, as I'm going to show you right now. You only have to write the name of the data frame followed by the pivot method and then specify 3 arguments. So the first one is the index. In this case, I'm going to reshape this data frame choosing the column foo as an index. This means that the column foo will be in the position where is right now the numbers from 0 to 5 on the left. Next, you have to define the column. So these are the new columns that we're going to see in our new data frame, the one that we're going to reshape. So in this case, I'm selecting the data inside the bar column as new columns. This means that A, B, and C will be the new columns in our new data frame. And finally, we have to choose the values we wish to show in this new data frame. So in this case, I'm choosing the base column, so all the values inside there will be shown in our new data frame. So this is the column that I'm selecting. And now I'm going to show you the result of this pivot method. So here it is. And as you can see here, we have the foo in the index, as I told you before, and the A, B, and C that are data from the bar column now are columns in this new data frame. Also, all the data inside this base column is the only data that is displayed in this reshaped data frame. And now let's see why it's sorted this way. So why 1 is here, 2 is here, 3 is here, and so on. So here the value is defined by the index or row and the column. So between 1, index 1, and column A is 1. And why that happens? Because if we go to our previous data frame or the original data frame that is here, we can find that here is 1, A, and the value that corresponds to that pair is the number 1. So let's pick another one. For example, 5 here. We have 2 and B. And if we go here to our original data frame, we have that 2 and B. The value that corresponds to that pair is 5. So that's why this value is here. And that's how this new data frame was reshaped. Okay, and finally we have the pivot_table method. And this one creates a spreadsheet style pivot table. So this is similar to the pivot table that we will find in Microsoft Excel, for example. And this one supports data aggregation. And to explain you more about the pivot_table method as well as the pivot method, we're going to see some examples in the next video. And this time we're going to write some code so you can understand much better what we're doing. Alright, now it's time to see how the pivot method works in action in pandas. So first, as usual, we import pandas as PD. So here I import this library, and then we're going to use a different dataset to work with this pivot method. So to read this dataset, we use the PD read underscore CSV method. And inside parentheses, we write the name of this dataset. So in this case is gdp.csv that you can find in the notes of this video. So this is the new dataset, and now let's have a look. I'm gonna run this one, and as you can see here, we have data about GDP per capita that is in this column, and basically this is how the GDP grow over the years for each country. So here I'm gonna tell you which are the columns we're going to use for this example. So first we're gonna use the country column that contains data about different countries. Then we're going to use the year column that, well, contains different years, and the GDP per capita that it's in this column. So basically what we want to do in this exercise is to obtain a different view of our original data set. So this data set that we're reading here with pandas has this view, but we want to get a different view to have a better analysis. So the goal of this exercise is to see the evolution of the GDP per capita over the years for each country. And then we're gonna put the country names in the columns. So the only data we're going to show in our new data frame is gonna be the GDP per capita that it's here. So I'm gonna show you now this with code, and let's write it here. But first, let's assign a variable to this data frame. So here I'm gonna write df underscore GDP. So this is the name of my data frame, and now I'm gonna show it, and it's here. So now I'm gonna copy this data frame, and to use the pivot method, I'm going to paste this one, and now write that pivot. Now we open parentheses, and now as you might remember from the previous video, we have to introduce 3 different arguments. And if you don't remember the 3 different arguments we have to introduce here, you can only press the Shift and Tab keys on your keyboard and you will get this. And here you can see the 3 arguments I'm talking about. So first we have to write the index argument. So we write index, and as I told you before, I want the year column to be the index of my new reshaped data frame. So I'm gonna set this year as the index of my new data frame. So I write here year. Next we write comma and press Shift and Tab to show this. So the second argument is the columns. So we write columns, then equal and open quotes. So here, as I told you before, I want the countries here listed in the country column. I want each country to be an independent column. So for example, here, let's say we have the United States. So I want the United States to be column number 1, then column number 2, China, then Australia, then Spain, and so on. So each country should have one independent column. So that's what we want. And to get that, we have to set the country column here to the columns argument. So here country, and that's it. Now again, Shift plus Tab to show this window here. And now the third argument is values. So here I'm gonna write values equal to open quotes. And here the only data I want to show here in my new data frame is going to be the GDP per capita, which is the one that is here. And now I'm going to copy this one and paste it here. So remember our goal. Our goal is to see the evolution of the GDP per capita over the years for all the countries listed here in this column. So here we're gonna execute this code and let's see the result. So here, Control Enter, and as you can see here, I have the new view of this data frame and it looks much better. It's more readable because we can see the GDP evolution over the years for each country. So now let's verify if everything is correct. So here we have the index year and here we have the year as index, so everything's fine. Then the columns should be country, and now we have each country in the columns, so it's correct. Next, the values are the GDP per capita, and yeah, we have here the intersection between the row and a column is a value that corresponds to the GDP per capita of that country in that year. So everything is working fine. And there you have it. This is how the pivot method works in pandas. Okay, now let's see how the pivot underscore table method works in pandas. So in this case, we're gonna work with a different data set, and to read it, we're gonna use the method pd read underscore Excel, because in this case, the dataset is not a CSV file, but an Excel file. So we use read underscore Excel for an Excel file. So in this case, the name of this dataset is supermarket underscore sales dot xlsx. And this is what we're going to see after you run this. And here you can see that we have different columns about what a specific person bought in a supermarket. And here, well, we have the branch, the city, the gender, and different data. So here, to make a pivot table, we're gonna first name this data frame, and I'm gonna name it df underscore sales. And now I'm gonna show it here, and okay, now it's here. Okay, the goal of this task is to see how much female and male spend their money in this supermarket. So to do that, we're gonna use the pivot table method in pandas. So first, I'm gonna copy this data frame, and now I'm gonna paste it here. And now we're gonna make a pivot table and add an aggregate function. Because remember that the pivot underscore table method allows us to add an aggregate function, and the pivot method doesn't support that. So we're gonna use the pivot underscore table this time. And now we're gonna introduce some important arguments. So the first one is the index. And in this case, if we want to see how much male and female spend in this supermarket, the index is gonna be the gender. So here, I'm gonna copy gender here, and it's gonna be here. Index equal to gender. So this is the first necessary argument. And the second one is gonna be the aggregate function. So we have to write A, double G, F, U, and C, and then equal to, and then write the aggregate function we want to perform. So in this case, it's gonna be a sum. So we write sum, and now everything is ready. So what we're supposed to get here is the information about the sales here in this data frame, but now divided by gender. So we have the female category and then the male category. So let's verify this. I'm gonna run this one. And as you can see here, we have this summary table or pivot table, and now it's divided by gender. So we can see how much female is spent here in the total column, and also how much male is spent also in the total column. And here in the quantity column, we can see how many products they bought, how many products female and male bought in this supermarket. And one detail you might have noticed is that only the columns that contain numerical data are displayed here. So for example, here branch and city that contain only text aren't here in this pivot table, because here in the aggregate function argument we indicated that we want to sum, and when we sum values we cannot sum text but only numerical data. So only the columns that have numerical data are displayed in this new pivot table. Okay, that's our first pivot table, and we can do even more. For example, we can select a pair of columns that we're interested in. So let's say we only care about the quantity and the total column. So we want only those columns. So we can get that. I'm going to copy this one. And to show you how to get only those two columns, I'm going to add a new argument. So here I'm going to write, and in this case, the name of the argument is values. So I write values equal to, and in this case, I'm going to select the quantity and the total columns. So I open square brackets because I'm going to select two or more columns, and inside I write the name of the column. So first quantity, I write here, and then total. So here too. So we're gonna get the same pivot table, but in this case only the quantity and the total columns are gonna be shown in this table. So I'm gonna execute this one, and here I got an error because I didn't include this comma, so I'm gonna add it here, and now everything should be fine. And yeah, we got the same pivot table, but only the quantity and total columns are displayed here. And here we can clearly see that female spent more than male in this supermarket. But we can get even more detail here. So far we know that female spent 167,000 in this supermarket. But with pivot tables we can even know in which product lines this money is spent. So let me show you here. We can see how the money is spent in this product line column. So we only have to add a new argument to this pivot table method. So I'm going to show you here. First, we copy this, and now I'm going to paste it here. And we're going to make a pivot table that says how much male and female spent in each category, or well, product line. So we add a new argument, and this one is going to be the columns argument. So I write columns, then open quotes, I add the comma, and here I write the name of this column that is product line. So I scroll up, I copy this column, and then we're going to see in which category is spent the money. So health and beauty, or sports, and so on. So now I scroll down, and here I paste it. And before I run this code, here we only want to display the total because we only want to see where the money goes, not the quantity. So only total, so I delete the square brackets too. And with total, we're gonna see where the money goes divided by gender. So here I run because it's ready. And now, as you can see here, we can see how much female and male spent in each product line. So we can quickly see, for example, that female spent more money on fashion accessories than male, and that kind of makes sense. And also in sports, women spent, or female spent more money than male. So we could easily see all of that by using the pivot_table method in pandas. And this is similar to the pivot table you will find in Excel. And that's it. That's how you make a pivot table in pandas. Alright, before showing you how to make visualizations with pandas, first we have to check the dataset, and also we have to make a pivot table so we can easily make the plots with pandas later. So first we have to import pandas to read this CSV file, and well, I have this import pandas as PD, so we just run this code, and now let's read this new dataset. So as you might remember, to read a CSV file, we have to use the read_CSV method. So we write pd.read_CSV, and then we write the name of the CSV file. So in this case, the name is population, and I'm gonna use this population_total.csv. So I pressed tab to get this the name. So we have now the name, and now I'm gonna assign this to a new variable. So the variable is gonna be df_population_row. So this row data, and now we're gonna have a first look at this dataset. So I paste this, and now I'm gonna run this too, and now we have this data frame. So here, as you can see, we have the population of many countries throughout the years. So for example, we have China here, United States, and India. So we have the population, and here I wrote the name row because this dataset was extracted using some web scraping techniques, and then it wasn't modified. So now we have to make some changes to reshape this data frame so we make it easy for us to make visualizations with pandas later. So what we have to do here is to make a pivot table to reshape this data frame, and that's what we're gonna do here below. So we're gonna make a pivot table, and we're gonna use the pivot method. So as you might remember, the pivot method returns a reshaped data frame organized by given index column values, but it's a pivot without aggregation. So this is what we want. So we only want to reshape this data frame. So we're gonna start by dropping null values. So we do that by writing the name of the data frame, and now I'm gonna just copy the name and I paste it here. And now to drop null values, we have to use the drop NA method. So I write drop NA, and then we have to run this. And as you can see here, we have the result, and it's a copy from this data frame. But if we want to save the changes that we make to the data frame, we have two options. The first option is to use the in place argument. So I write in place and then set this to true. So if we do this and we run, all the changes that we make to the data frame are gonna be saved. And the second option is to do something like this, to overwrite the content inside this data frame. So we do something like this. We write df_population_row is equal to the same data frame, but that drop NA. So we're overwriting the content inside this data frame. So I'm gonna choose the first option just to reduce some code. So I write in place equal to true, and now I run, and this new data frame shouldn't have any null values. Okay, now it's time to make this pivot table. So first I'm going to show you what I'm going to do so we have a better idea before writing the code. So here we have the original data frame, and what we're going to do is to reshape this data frame. So I want the year to be in the index. So the year column, I want it to be here in the index instead of 0, 1, and so on. And then I want the country column, or the values inside the country column, I want it to be here in the columns. So for example, I want China here in one column, then United States in another column, and then India in another column. And I want the population data inside the data. I wanted this to be the only data here. So to do that, we have to use the pivot method, and that's what we're going to do here below. So let's do it here. So first we have to write the name of the data frame, which is this one, and then write dot pivot. Then we open parentheses, and here let's see the arguments that this pivot method accepts. So I press Shift and Tab to get this helpful, let's call it cheat sheet. And now we have the arguments that this pivot method accepts. So first is the index, then the column, and then the values. So as I told you before, the index, I want it to be the year column. So we have to write index equal to, open quotes, and I write year. Then comma, and let's check another argument. So the next argument is the columns. So I want the columns to be the country, so the data inside the country columns. So here I write columns, then I open quotes, and here I write country. So country. And now the last one I think is values, and yeah, it's values. So I want the values to be the population data. So let me see if that's correct. And yeah, it's here. So population, and I'm going to press enter here so it looks much better. And now population, it's here. So I have the three arguments, the index, the columns, and the values. And now I'm going to reshape my original data frame. So here I press Control Enter. Now, as you can see here, we have the countries in the columns. So here we have many countries. It's from the first country, Afghanistan, to Andorra, Argentina, Uruguay, and many other countries. So we have also the year. So it's here, the year from 1955 to 2020. So we can see here the evolution of the population throughout the years for all the countries in this data set. But as you can see, there are many countries. So what we can do here is to select just some countries so we can simplify our visualizations later in Pandas. So here I'm going to select some columns, but first I'm gonna name this new data frame. I'm gonna give it a name. So I'm gonna name it df_pivot. So this is my new data frame. Now I'm going to rearrange this, and now it looks much better. So now I'm going to run this, and now let's select some countries. So I copy this pivot data frame, and now we open square brackets, double square brackets to select two or more columns. And here let's write some countries. So first United States, then let's say India, then China, two more countries, Indonesia, and last but not least, Brazil. So here we have the 5 countries. So I run here, and we have these 5 countries and the population from 1955 to 2020. So great. Now we simplify this data frame, and now I'm going to overwrite the content inside the data frame, df_pivot, and I'm going to write here df_pivot equal to df_pivot, and with this selection. So I'm overwriting the content. So I press Control Enter, and our new df_pivot is here. So we have it here, and now I'm going to show it to you. And this is our new df_pivot data frame. And that's it. Now our data is ready. So we can use it to make great visualizations with Pandas. And that's what we're gonna do in the next video. Okay, now it's time to make some visualizations with pandas. And here I have the data frame that we created. This is the pivot table we created in the previous video. And as you can see here, we have 5 countries in the columns, and here we have the year in the index from 1955 to 2020. So what we're going to do now is to make our first visualization. So I scroll down here, and the first one is going to be line plots. So here, first, to make this visualization, I'm going to copy the name of the data frame and I paste it here. So now to make plots with pandas, we have to use the plot method. So we write .plot, and now I open parentheses. And one necessary argument we need to introduce is the kind argument. So I write kind, now equal to, and here I have to write a kind of plot we want to make. So in this case, it's a line plot. So we write line. And this is actually the mandatory argument we have to introduce here. And now we can run this code. So I press Ctrl Enter. And as you can see, here I have the line plot. So in this line plot, we can quickly see the evolution of the population throughout the years. For example, China and India, which are green and orange lines, they had some fast growing population, while United States, Indonesia, and Brazil, they have a lower population, and also the population didn't change so much in the past 50 years. Here we can add more arguments to this plot method to customize this line plot. So here we can introduce another argument, which is the X label. And this X label is what you can see here. Here, when we created this line plot, by default, it was assigned this year label, but we can change it. So for example, let's say we want to write year, but now with capital letter. So we write year here. And now let's say we want to add a new label here in the y-axis. So here we have only to write y label and then equal to open quotes, and here we have to write the name we want. So in this case, I'm going to write only population. And finally, we can also add a title. So we can add any title we want. In this case, I'm going to write the name of the argument first, title, then equal to, and then the name of the title is going to be, let's say, population from 1955 and to 2020. So this is the title. So let's run this. And now, as you can see here, we got the title, population, 1955 to 2020, and the X label and Y label were modified too. Finally, we can add one more argument. In this case, the argument is the size of the figure. So to change the size of this figure, we can add the argument named fig size. And this is a tuple, so we have to open parentheses. And now to edit the size, we have to add 2 arguments. The first is the size of the x-axis, and the second the size of the y-axis. So in this case, I'm going to set it to A and then 4, which means that the x-axis is going to be large, while the y-axis is going to be short. So here, I'm going to run this code and let's check it out. So here the figure has a different size, and that's how you can customize this line plot. Okay, now let's make a bar plot with pandas. So the first thing we have to do is to select only 1 year. So the bar plot only accepts just 1 year, and we can plot there the population of different countries. So let's select 1 year of this data frame we have before. So I'm going to copy the name of the data frame. So you can check it out again. So this is the data frame, and we're going to select 1 year. So to do that, we have to use the index attribute and then the isIn method. So first I'm going to show you the index method in case you don't remember. So here the index attribute allows us to see all the index in this data frame. So we have here from 1955 to 2020. So that's what the index attribute does. And now if we use the isIn method, we can filter out some index. So here, let's say we want to select only the 2020. So I copy 2020. And now here I write equal to, and first I'm gonna make the selection. So it's here. And now I'm going to show you what's the result. So here I press Control Enter, and the result is this little data frame that only contains the population in the year 2020. So this is important because the bar plot is supposed to show only the population in this year. So here we have it. And now what we're going to do is to name this data frame. So here we write equal to, and then let's give it a name. So I'm going to name it df_pivot_2020. So here I press Control Enter, and now I'm going to show this new data frame. Well, again here, and here one little detail I have to tell you is that when we make bar plots, we have to put text data in the index. So here the name of the countries should be in the index. So to do that, we have to use the transpose method. So this transpose allows us to switch rows and columns and vice versa. So here we can easily do that by writing the data frame, the name of the data frame, and now .t. So if now we run this code, we can see here that we have this. So now the year 2020 is in the column and not in the index anymore. And the country names are in the index here. So this is the format we need to have before making the bar plot. So now I'm going to overwrite the content in this data frame. So I write df_pivot_2020 equal to this same data frame, but .t. So here I run this, and now it's time to make the bar plot. So here I copy the name of the bar plot, and now I use the plot method. So I write plot again, open parentheses, and the first argument is the kind. So I open quotes and we write bar. So now it's ready and we can run it. So as you can see, we have a basic bar plot, and it has some default values like the name of this X label, and also the default color is blue. And we can customize this bar plot a bit more. For example, I want a different color, so I write the color argument and then open these quotes, and let's say I want it to be orange. So I write orange, and also we can change the X and Y label. Actually, I can copy this here, so I can save some time here. So X label and Y label are here, and let's paste it here. So X and Y label. And finally, I can add also the title, which was here. So I copy and paste it. But in this case, the title is a bit different because in this case, it's not from 1955 to 2020, but it's only 2020. So here I have only 2020. And now let's run this to see the results. So as you can see here, we have a title, the X and Y label, and the bar plot is in orange. So that's how you customize the bar plot. All right, so far so good. Now let's go one step further by making bar plots grouped by n variables. So here we have to select a group of years to make these bar plots grouped by n variables. So I'm going to copy this code we used before to select only the year 2020. I'm going to copy this. And in this case, I'm not going to select only one year, but a group of years. So let me show you here. Instead of choosing only 2020, I'm going to show you the pivot table again so you can easily understand. So instead of choosing only 2020, I'm going to choose some other years here. So I'm going to delete this and I'm going to write it here. So let's say 1980, 1990, then 2000 and 2010, and well, finally 2020. So we have a group of years here and we're selecting this using the index and is_in method. So here I'm going to give it a different name. In this case, since it's a sample, I'm going to write df_pivot_sample. Now I'm going to show you this one so you can see what this looks like. So now we have 5 countries and now 5 years. So now I'm going to assign this to my data frame. So df_pivot_sample. I run this and now we have this new data frame. So it's time to make this grouped bar plot. So here we write the name of the data frame and then the plot method. So we write that plot. And now let's add the first argument, which is kind and equal to bar. Now we run this. And as you can see here, we have the plots or the bar plots grouped by year. So here's 1980 and 1990 and so on. And you can also add the same arguments we added here. So for example, I can add the X and Y label. So I can do it here. I'm gonna do it fast. So here I run, and as you can see here, we modify the X and Y label. And that's it. That's how you make bar plots with pandas. Okay, in this video, we're going to learn one of the most common charts that we can make in pandas and actually in any other visualization tool. And these are pie charts. So before we make this pie chart, first let's give a look to the data frame we're going to use. And in this case, to make a pie chart, we're going to use the same data frame we used for making the bar plot because it follows the same logic. So here I'm going to copy the data frame we created for the bar plot, which is this one, df_pivot_2020. So this is what we created before by using the index attribute and the is_in method. So here I'm going to copy this. And now I'm going to show you here so you can remember what's inside this data frame, and it's here. So here, as you can see, we have the column 2020 and the countries are in the index. So everything is fine. That's what we need. That's the format we need for making the pie chart. But there is one little thing we have to modify, and this is the column name. Because now it's 2020 and this is a number. It's actually, I think it's an integer. So it's not a good practice to have numbers in columns. So what we have to do is to make this a string. And to do that, we use the rename method. So we write that rename, open parentheses, and now we use the columns argument. So we write columns, then open these curly braces, and now we write the name of the column we want to change, which is 2020, and we're going to make this integer value into a string. So we open quotes and write 2020. So apparently they are the same, but the green one is an integer and the red one is a string. So now to save these changes, I'm going to write in place equal to true. And I'm going to run this. So now we can make the plot. Here I'm going to write the name of the data frame. And now I'm going to use the plot method. So here I write that plot. So the first argument is kind. And here I write pi. So the kind is pi. And now I run this. And here I forgot to include the y argument. And I'm going to write it here. So the y argument is supposed to have the data. So in this case, I'm going to show you here again the data frame. So the data is here in 2020. So we should write here 2020. So I'm going to delete this. And here in the y argument, you write the column that has the data. So that's what we did. So now I run this. And now we finally have our pie chart. So here is the pie chart. So that's how you make a pie chart. If you want, you can even add another argument like the title. For example, here, I can say that this is the population in 2020, but in this case in percentages. So write this, and now we have this title. So that's how you make a pie chart in Pandas. Okay, in this video, we're gonna learn how to make box plots with Pandas. A box plot is a graph that shows us how the data is spread out. And the box plot shows 5 important numbers. First, it shows the minimum score of the data, then the first quartile, also known as Q1, then the median, then the third quartile, also known as the Q3, and finally the maximum value of the data. Okay, now let's make this plot in Pandas, and we're gonna use the data frame that we created before that is named df_pivot. So here I have it, and I run it so you can remember what this data frame looks like. Okay, let's start by making a single box plot, and then we're gonna make multiple box plots. So here, since we only wanna make a single box plot, I'm gonna pick one country here. So here I write df_pivot, open square brackets, then quotes, and then write the name of the country. So in this case, United States. So now to plot this box plot, we only have to use the plot method. So here we write .plot, open parentheses, and as usual, we have to write the kind argument. So here, kind equal to, and in this case, is going to be equal to box. And that's all we need. So now I run this, and as you can see here, I have the box plot. And here we can add more arguments to customize the box plot. For example, the color argument, I'm going to set it to green. And also I'm going to add a Y label. And this one is going to be equal to population. So I run this, and now we have this label in the y-axis, and the box plot is green. And as I mentioned before, this box plot contains 5 important values. So the one we have here is the minimum value, and this one is approximately 1.7. Okay, then the one I'm showing right now is the Q1, also known as first quartile. It should be here 2.2. Then this one here in the middle is the median, and this one should be 2.7. And the one here is the third quartile, so Q3. And this one is the maximum value in the data. All right, now let's make multiple box plots. So here I'm going to write df_pivot. And in this case, I'm not going to select a specific country because we're going to make multiple box plots. So we're going to get one box plot per country. So here I just write df_pivot and then .plot, then parentheses. And now the first argument is kind, and here I'm going to set it to box. So now I can run this one, and as you can see here, I got 5 box plots. and each of them represent one country. Here, if we want, we can add also the color argument equal to green, and also the Y label argument. In this case, I'm going to set it to population. So as you can see here, the box plots are in green, and now we have the population label. And that's it. In this video, we learned how to make box plots with pandas. Alright, in this video, we're gonna make a histogram with pandas. But first, let's see what's a histogram. A histogram is a graph that organizes a group of data points into ranges. In the graph, these ranges are represented by vertical bars, and they show the frequency distribution of the data. Alright, now let's make this histogram, and here I'm going to use the df_pivot data frame. So here it's this data frame, and here we can choose any country to make its histogram. So I'm going to choose here Indonesia, and I open square brackets and write the name here. So now I write dot plot to make the histogram, and here I add the kind argument. So I set this equal to hist, and then I can run this to make the histogram. So I run, and here I got the histogram of the country Indonesia. But that's not all. Here we can make multiple histograms in this plot. So here I add square brackets, and now we add one more country. So here I'm going to write United States, and now I'm going to run this. Here I wrote incorrectly, so I modify, and now I run again, and here we got a histogram of Indonesia and United States. And that's it. That's how you make a histogram using pandas. In this video, I'm going to show you how to make scatter plots in pandas. Scatter plots are used to plot data points on a horizontal and a vertical axis in the attempt to show how much one variable is affected by another variable. In this example, we will plot years versus population, and we will see how much the population is affected by the year. So to do that, I'm going to use the data frame that we had at the beginning. So this data frame that we got after reading this CSV file, and it has this format with country, year, and population in separate columns. And this format is going to help us make scatter plots easily, because each row will represent a dot in the scatter plot. So here, now I'm going to paste the value of this data frame, and now I'm going to make some little changes. So the first thing I'm going to do is to select some countries from this data frame. So to do that, I select the countries column. So I write country inside square brackets, and now I use the is_in method. So here is in parentheses, and now I select some countries. So I open the square brackets. And now I'm going to choose some countries. So United States, and also India, then China, Indonesia, and finally Brazil. Okay, I have these 5 countries, and now I'm going to set this to a new data frame that I'm going to name df_sample. So now I run this, and here I forgot to make the selection. So I'm going to select this data frame. So I open square brackets and write the same name of that df_population_row. And now we created this df_sample data frame. So let's see how it looks. So here I print it, and now we have this data frame, but now we only have 5 countries. And we reduce the number of countries because we don't want that the scatter plot is overpopulated. As I told you before, the rows represent one dot in the scatter plot. And if we have many dots, we won't be able to see the dots clearly. But with 5 countries is fine. Now that I have this data frame, I'm gonna plot this with dot plot, and now add the kind parameter. So kind equal to, and here scatter. Now the 2 other parameters we have to add are the x and y parameter. So here I write x, and then I write y. So here x and y. And this represents the values that are going to be in the x and the y axis. So first, in the x axis, I want to show the year. So I write year. Now we have this one here. And now in the y axis, I want to show the population. So I write population. And that's it. now we can plot this scatter plot. So I run this, and here we get this scatter plot, and each dot represents a row in the data frame df_sample that we have here. Here we see that the dots follow a pattern, and this is not so good because scatter plots are much better when the dots don't follow a pattern. But I'm just making this scatter plot so you know how to make the scatter plot with the plot method. So now we can control the size of the dots. So here I could write S, the S parameter, and here let's write 80. So we make it bigger, and now we see that the dots are bigger. Also, we can control the color of this data frame. So I write here color, and now let's set it to green. And now let's see the result. So now we see that all the dots are in green. And this isn't so good because it's hard to recognize what category each dot belongs to. So for example, we don't know if this dot belongs to the country India or United States or Brazil. We only know that the year is between 1980 and 1990, but we don't know exactly the year. And also the population is between 1 million and 1.2 million, but we don't know exactly how much the population is for this dot. I could show you how to set different colors for each dot based on the category, but that will involve importing Matplotlib and also writing a for loop and more lines of code. Fortunately, there is an easy approach that helps us set different colors for the dots based on the category and also see the values behind each dot. And that's by making interactive visualizations. And I'm going to show you how to do that in the next video. Alright, so far we made a pivot table and many plots using pandas. And in this video, we're going to learn how to export the pivot table and also the plots we made with pandas. So let's start by exporting the plots we made with pandas. And to do that, first we have to import matplotlib. So we write import matplotlib.pyplot. And then we write as plt. So this plt represents this matplotlib.pyplot. So now we run and we imported matplotlib. And now we can use this plt to save the plot. So we write plt.savefig. And now we open parentheses, and here we have to write the name of the file we want to export. And here I'm going to write my_test.png. So this is the extension and this is the name of the file. And now before exporting this file, I'm going to show you something here. So probably you notice that when we make the plots with pandas, we get these words here that says access, subplot, and all of this. So we can get rid of these words by using the show method. So we write plt.show with parentheses. And if we run this, we're going to export this figure and also we're going to get rid of these words. So let's try. So I run this, and as you can see here, all those words disappeared. And also we exported the figure to a PNG file. And now this file should be located in the same folder where you have this Jupyter notebook file. Okay, I'm gonna open that file, but first I'm gonna export the pivot table. So here I copy this df_pivot and I paste it here. And now to export it, we have to use that to_excel method. So we write to_excel, and now I open parentheses. Here we write the name of the file where we're going to export this pivot table. So in this case, I'm going to name it pivot_table.xlsx. So this is the extension of Excel, and this is the name of this file. So now I run this, and now the pivot table should be exported. All right, now I'm going to open the Excel file and the PNG file we created. So it's here, and here we have the plot we exported and also the pivot table. So as you can see here, the plot looks exactly the same as the one we created here with pandas, and the pivot table is the same. So I'm going to show you how the pivot table looks, and here is the pivot table, and here is the pivot table we exported I open it in Google Sheets and looks exactly the same. And that's it. In this video, you learn how to export data frames as well as plots. Okay, in the previous videos, we learned how to make visualizations such as line plots, bar plots, pie charts, box plots, and more with pandas. But all of them were static visualizations. This is good, but sometimes you want to interact with your visualizations to know the data behind a line plot, for example, or to know the values behind this bar plot. This is not possible with the traditional visualizations that we have in pandas, but there is a library named Plotly that helps us make interactive visualizations in Python. Fortunately, this library works good with pandas. And in this video, I'm going to show you how to make interactive visualizations with pandas using Plotly under the hood. Okay, to easily create interactive visualizations, we need to install cufflinks. This is a library that connects pandas and Plotly, so we can create visualizations directly from pandas. In the past, you had to learn workarounds to make them work together, but now it's simpler. And you don't even need to learn the syntax to make visualizations with Plotly, but you can use the same syntax we learned so far to make visualizations with pandas, with some little changes. Okay, first we have to install the Plotly library. So to do that, here we write pip install and then Plotly. Remember that you need to add this exclamation mark to run commands from Jupyter Notebook. So this is a command and we're running this to install Plotly. So I press Ctrl Enter to run this. And now let's wait until Plotly is installed. So just a couple seconds. Okay, I got the message that Plotly was successfully installed. And now that I have Plotly installed, I'm gonna install another library, which is cufflinks. And as I told you before, this library connects pandas and Plotly. So let's install this library. So I write this exclamation mark and then pip install and then we write cufflinks. So CUFF and links. Now I run this and here we have to wait a couple seconds. Okay, I got the message that it was successfully installed and now we can start making interactive visualizations with pandas. So here I'm gonna delete this cell and let's import the libraries that we need to make interactive visualizations. So first we import pandas. So import pandas as PD. Then we import cufflinks. So import cufflinks as CF. Then we have to import display and HTML from ipython.display, and this will help us display the interactive visualizations in Jupyter Notebook. So here I write from ipython.display and then import display, HTML. And finally, I'm gonna edit the default configurations of these cufflinks by writing cf.set_config_file, and inside parentheses I'm going to change some parameters. First, the sharing parameter, I'm going to set it to public. Then the theme, I'm going to set it to ggplot. And finally, the last parameter is offline, and I'm going to set it to true. By the way, here I'm using the ggplot theme, but you can choose any theme you want. You only have to write here the command cf.getThemes with parentheses. And here you will see all the themes. Here I didn't get it because I didn't import cufflinks as CF, but I'm gonna import here. So I import, this might take some seconds because it's the first time. And now I imported these libraries and now I run this. And here we get all the themes. So here is ggplot. This is the theme I'm gonna use for this video, but you can choose any theme you want. You only have to set it and then test it out and see if you like it. Okay, now before we make interactive visualizations, I'm gonna show you the syntax, which is similar to the static visualizations, but with some little changes. So let's say we have a data frame named df. So if we want to make an interactive visualization, we have to write the iPlot method, which is that iPlot and then parentheses. So this one looks similar to the plots we make before for static visualizations, but here is not plot, but iPlot. So the I is for interactive and well, plot for the plotting that we're making. And inside you have to add the parameters, the kind parameter, which is similar to the static visualization. And overall, the behavior of this iPlot is similar to the plot method, but it will have some changes in the parameters or in the way it behaves. So let's review each visualization and let's see how the iPlot method works. Okay, to make these visualizations, we're gonna use the same dataset we use for static visualizations, and I have here the code, so I don't have to write it again. And this is the name of the dataset or the CSV file, population_total. And here we have the same data frame. So I'm gonna run and I'm gonna show you the data frame, so you remember how this one looks. So here we have the country, year, and population, and we're gonna make visualizations, but this time we're gonna make interactive visualizations so we can see the data behind the plots. Okay, now I'm gonna copy and paste all the code we used in the previous videos to make the pivot table, so we focus only on making interactive visualizations. Okay, here I pasted the code, and these are all the operations we made to get this df_pivot data frame. So we read the CSV file, then we drop some null values, make a pivot table with the pivot method, and then select some countries. So here I'm gonna show this df_pivot. So I run this one, and here we have this data frame that will help us easily make the interactive visualizations. Okay, now before we start, I'm gonna delete these 2 lines of code or 2 cells, and here I'm gonna start with the line plot. So I delete this one too, and here we start with a line plot, but this time it's going to be an interactive line plot, so we will be able to see the data behind the lines. So here let's start by writing the name of the data frame, which is this one, so df_pivot, and then we write the name of the method, so that iPlot. So after this we write kind, and then we write the type of plot we want to make. So here is line. And now this is everything we need to make this basic line plot. So let's have a look. I'm going to run this one. And here we got this plot, which is a bit big, but anyway, you can see clearly. And the cool thing about this interactive visualization is that if we point and drag this plot, we can see the data year by year. So here you see the population in China in 1970. Here in this blue line, you can see much better the numbers. And here we see the population in India in 1975. So here we can see how it grew over the years. And here we see the population in 2019. So this is cool because you not only see the plot, but you can see the data behind and you get more detail about this line plot. Okay, now let's say we want to add some labels here, the X label and the Y label. So we can do this also in interactive visualization. So we can add some parameters to the iPlot method. So first, let's add the X label, but in this case, the X label that we had here in the line plot, here, this is the static visualization we made previously. Here, the parameter was called X label, but now in the interactive visualization, this one is called X title. So keep that in mind. So I write X title, and here I'm gonna name it years, and the other is gonna be population. So here I write years, and then Y title, and in this case is gonna be population. So now I'm gonna add a title, and here the title is just name title, and this one is gonna be name population, and I wanna add the years, so 1955 to 2020. So here it is, and I run this, and now we see the title, And also we see the years in the x-axis and the population in the y-axis. And that's how you make a interactive line plot with pandas and also with Plotly. Alright, before we move on to the next visualization, I want to show you this bar that comes with Plotly. And here we have different options. For example, we can download this plot as PNG with this camera icon, or we can make zoom. So I click here and let's see what happens. So now if I make this, so I made a selection and you see that we have more details in these years for these two countries. So here let's make another selection and we zoom in again. So here to zoom out, let me see how to do it. And I think I can do this with this zoom out button. So here I zoom out and we get this line plot, but now it's a bit smaller. And here again, zoom out and we can see all the line plot, but now we have more years. So here we have 1940 and let's zoom in now. And you can see now that it fits much better, but now it's too close, but you can control this much better with these zoom in and zoom out options. But also you can auto scale with this option here. So you get the line plot as it was before. And finally, we got this reset axis and let's see what this does. And I think this one fixes the axis position or the tick's position. But anyway, let's check another one. So the pan option helps us move in this plot so we can see other parts of the plot, as you can see here. And finally, we have this produce with Plotly. If you click on it, this is going to send you to the Plotly website. So let's try it out. Here we see, the Plotly website. And anyway, those are all the options in this Plotly bar. And now let's make our next plot. So here I'm going to make a bar plot. So I write bar plot. And now let's make this bar plot. And as you might remember, we have to make some changes to the original data frame to make this bar plot. And to avoid repetition, I'm gonna copy and paste those lines of code so we can focus only on making this interactive bar plot. Okay, now we have the code that helps us make this data frame df_pivot_2020 that we use to make the bar plot. And now I'm gonna run this code. And here, the first line of code helps us select only the year 2020. And the second one transposes the data frame, which means that we switch the rows and the columns. So here, I'm going to show you the data frame. So I print it. And here, this is the data frame. So with this data, we're going to make the bar plot. And in this case, it's going to be an interactive bar plot. So first, we write the iplot method. So iplot. And inside, we write first the kind parameter. This one is equal to bar. And then we're going to give it a color. So I'm going to set it to light green. Then I change the name of the labels, the X and the Y label. So I write X title equal to years. And then also the Y title. Remember that in static visualizations with pandas, this is called X label, but in interactive, this is called X title. So here I write Y title. And in this case, it's going to be the population. So with this, I'm going to run the code. And now let's see the visualization that we got. So this is the bar plot. But now if we select one bar, we get the value that it has. So for example, here in the traditional or static visualization, we only get this. So we don't know how much population India has in 2020. We can say that the population in India in 2020 is approximately close to 1.4 billion, but we don't know exactly how much is the population. But if now we select the India bar in this interactive visualization, we get that the population is 1.38 billion. And we can see also the other countries. So for example, United States, 331, and China, 1.43 billion, and so on. In this case, it doesn't make so much sense to use the zoom in or zoom out. So now let's move on to the next visualization, which is making bar plots grouped by 2 or more variables. Okay, here I pasted this code that selects some years, so the years between 1980 to 2020, and we're going to use these years to make multiple bar plots. So here I run, and now I'm going to show you the df underscore pivot underscore sample. So is this one. So now we have multiple years, and this is going to help us make multiple bar plots. So now I write the iplot method. So here I write .iplot, then the first parameter is kind, and I set it to bar, and let's see how this one looks. So here I have these multiple bar plots, or bar plots grouped by 5 variables. Here we can see in detail the population of each country in the year we want. So let's pick this one. So it's India in 2020, and it's 1.38. Let's pick one more, and for example this little one, and it's United States in 1990. The population was 252 million. Okay, so far we made interactive bar plots and also interactive line plots. And you can argue that maybe it's not so useful to make interactive visualizations in bar plots because the detail is not so much. I mean, you only get one value, but maybe in line plots it's more useful because you get more values behind one line. And the next visualization we're gonna see is more relevant when it's interactive. Okay, the next visualization we're gonna see is the pie chart. And here I have this first line of code that helps us change the name of the column 2020. So here I run this one. Now let's make this interactive pie chart, and then I'm going to explain you why I think this pie chart is more relevant when it's interactive than when it's static. So first I copy this data frame, and now I'm going to use the iplot method again. Here I added the kind parameter, and now I set this equal to pi. Then I'm going to set the values equal to this column that is 2020. So now I write 2020, and now this pie chart is ready. So I'm gonna run this one, and here I got an error because I forgot to add the labels. So I'm gonna add the labels parameter. So labels in here equal to, and now I'm gonna show the df underscore pivot underscore 2020 data frame, and here the labels is the country because here we have the names of the elements in this pie chart. So here I write country, and this is also our index. So here country, and now I run this, and I forgot to mention that we have to set this country as a column. So here, unlike the plot method, for making pie charts, we need to set this country index to column. So in the plot method, we could make this pie chart with this country as index. But in the iplot method, we need to set this country index as column. And to do that, we have to use the reset underscore index method. So here, I'm gonna do this. So I write dot reset underscore index parentheses, and here you see that the country index is not anymore an index, but now is a column. So now to save the changes, I'm gonna overwrite the values in this data frame. So now I run, and let's see the results. I'm gonna run this iplot method, so to make the pie chart. So I run this, and now we verify that this labels parameter only accepts columns and not indexes. So keep that in mind. This is a difference between the iplot method and the plot method. Okay, now we have the pie chart, and we can see in detail the percentage that each element takes. So for example, India takes 37.9% and the US takes 9.1%. So this is helpful, so we can see in detail the percentages. And here in the plot method, it wasn't possible. We could add a parameter that shows the percentages in each portion, but that might require more lines of code. But in this interactive visualization, we got this with the same lines of code. And to make this even much better, we can play with the visualization, so we can hide some elements. For example, I want to hide India. So if I hide India, we only see the United States, China, Indonesia, and Brazil. And also the percentages were calculated again. So all of them sum 100% because we're not considering India as an element. So let's show India again, and now let's hide China and let's say also India. And now we see in detail the proportion between these three countries without considering the countries with the largest population. And you can play as you want with this interactive pie chart. And this is something you cannot do with a static pie chart. So this is one of the advantages that the interactive pie chart has over the static pie chart. Okay, if you like this interactive pie chart, I think you're gonna like even more the next visualization. Okay, the next interactive visualization is box plot, and this interactive box plot is way better than the static box plot because we can see in detail the parameters that the box plot has. For example, the Q1, Q3, the minimum value, the maximum value, and the median. All of that we cannot see on the static visualization, but on an interactive box plot we can easily see by just pointing at those values. Okay, now let me show you how to make a box plot. So first we write the name of the data frame, which is df_pivot. Let me check it here so I don't make a mistake. So yeah, it's df_pivot, but unlike the previous plots, we're going to select only one country. So we make only a single box plot. So here I write df_pivot, and now I'm going to choose the United States country. So here, United States, and now the D, and here I'm going to use the iPlot method. So the kind parameter is going to be equal to box, and here I'm going to plot it, and let's see the result. So here we have this box plot, and also if we point at this box plot, we automatically get all the values of this box plot. So we can see that Q1 is 219 million, the Q3 is 323 million, and we also see the maximum and minimum value. In this box plot, we don't have outliers, so we don't see the outliers, but if we had outliers, we will be able to see the values of those outliers too. Okay, now to move on to making multiple box plots, I'm going to customize this box plot much better. So here I write color, and now let's change the color to green. And also let's add one more parameter. So also I'm going to add a title for this one. So y title equal to, and this is going to be population. So now we run, and now we get this box plot, and we see that it's green, and also that the y label is population. Great, now let's make multiple box plots, and let's do it below. So here I write df_pivot, now iPlot, and here the kind parameter, so again box. Now we write the y title to add a name for the y-axis. So this one is going to be population. And now let's run this and let's see the results. So here we see the 5 box plots, and each of them represent one country. So here we have United States, India, and all the countries. And we can see in detail all the values that correspond to these box plots. And this is cool because in the static box plot, you will have to calculate those values on your own, following some equations, as I'm going to show you in some videos. But with interactive visualization, you don't have to do that. You only have to point at the box plot and you immediately get the values you want. Okay, now let's make interactive histograms. And to do that, first, I'm going to write the name of the data frame, which is df_pivot. Now I select one country. So in this case, United States again. So here I have United States. Now I use the iPlot method. Then I add parentheses, and the kind is going to be equal to hist for histograms. Now I add a label for the x-axis, and this is x title, then equal to population. Now I run this and we get this histogram, and we can see the values inside each bin. So the first one has 3 values, as you can see there. The second one has 4, the third one has 4, and the last one has 7 values. So Here we can control also the number of bins. We only have to add the bins parameter and now set it equal to a number we want. So now let's say we want 3 bins. So I write 3, now run, and instead of having 4 bins as we had before, now we have 3 bins. So the first one has 3, the second one has 8, and now the third one has 7. So we rearrange these bins. Okay, now we can add even one more histogram. So we make multiple histograms in this one plot. So here, the only thing we have to do is to add one more element to this selection. So I add 1 square bracket, and here I add one more country. So in this case, let's add Indonesia. So Indonesia here. And with this, we should get 2 histograms in this plot. So let's run this. And now you see here that we have 2 histograms. And the cool thing about interactive visualizations is that we can play also with this plot. So here I can hide Indonesia, and also I can hide United States. So we can see the histogram we want. And this is something you could do also with the box plots here. With the multiple box plots, you could hide any value you wanted. So you only focus on the country you want. And this is very cool because this is not possible with a static visualization. Finally, we're going to see a plot that is more relevant when it's interactive. And I'm talking about the scatter plot. This one is more relevant because in the static scatter plot, you don't see the values behind all the dots that are in the scatter plot. But in an interactive visualization, you can see the values of all the dots that are in a scatter plot. And now I'm going to show you so you understand much better this. So first, df_pivot, so this data frame, and now I write the iplot method, so that iplot, and here the kind parameter as usual equal to scatter, so double T, and now I add the mode. In this case is going to be markers mode. So I run, now I scroll down, and now we have the scatter plot. This one looks like a static scatter plot, but now if we select any dot, we will see in detail the value behind a dot. So for example, China in 1985 had 1.07 billion population. And we can see all the values behind all the dots in this scatter plot. Again, you can hide any country you want. For example, I only want to show Brazil. So here I have the scatter plot of Brazil, and this scatter plot of population doesn't make so much sense because this follows a pattern, and usually scatter plot is useful when the data doesn't have a pattern. But still, I think you get the idea of the usefulness of interactive scatter plots. And that's it. In this video, we learned how to make interactive visualizations with pandas. We learned the advantages that interactive visualizations have over static visualizations. And also we learned the differences and similarities between the iplot and the plot method. Welcome to this section. In this section, we're going to learn how the group by and the aggregate functions work. So we're going to group the data frame we have by some categories, and then we're going to perform some operations like counting the elements, calculating the mean, calculating the sum, and so on. But first, let's check the data frame we're going to use in these videos so we can understand much better the concepts we're going to see in the following videos. So here I'm going to start by importing pandas. So I write import pandas as PD, and now I run this one, and now we have pandas imported. So now I'm going to read the CSV file that we're going to work with, and in this case it's going to be a car sales CSV file, and this one shows all the information about car sales and different columns that we're going to analyze. So here I'm going to use the pd.read_CSV method, and this one is going to help me read the CSV file. So now I open quotes, and now I write the name of this CSV file, which is car underscore sales. Okay, now it's time to read this CSV file. So I run this, and now we have this data frame, and we have different columns about these car sales. And here I'm gonna select some columns that we're gonna use in the following videos, and I'm gonna explain you what type of information each column has while I'm selecting those columns. So here I'm gonna write the name of the data frame, which is I don't have the name, so I'm gonna assign it now. So in this case, I'm gonna set the name df underscore cars for this data frame, and now I run. So now I have the name of this data frame, which is df underscore cars. And now I'm gonna select the columns I want by writing double square brackets, and here I'm gonna list the columns I want. So first I gonna here print the data frame, and here we have the data frame, and I'm gonna select some columns, and the first column I'm gonna choose here is the manufacturer column. So here I open quotes, and now I paste this manufacturer, and this column has information about the company that created this car, for example Audi, Volvo, and so on. Okay, now let's select the next column, and here I'm going to choose the sales underscore in underscore thousands column, so this one. So now I copy this and I paste it here. So this column has the sales of the car in thousands, and I suppose that's in dollars. Okay, now let's select the following column, and this one is vehicle type, and is this column. So now I copy and paste, and this column has information about the type of this vehicle, and there are two types of vehicle: passenger and car. And to know the types of values that is inside this vehicle type column, we can use the value counts method. And in case you forget about this method, we only have to use the name of the data frame. We write this, and then that value underscore counts. So now parentheses, and now I have to add the name of the column. So here I copy and paste it. And after this, we run, and we get two types, so passenger and car. So more vehicles are passenger type, and a few of them are car type. So now we know about this, and now I delete this, and here I have the column. Yeah, it's here. So next I'm gonna choose the price in thousands column, which is this one, and this one has the price of each vehicle. So I'm gonna copy and paste it here. So I add this new column, and now I'm going to choose another column, which is the engine size. Each vehicle has different types of engine size, and we're going to see that when we group the engine size later. And here I'm going to copy and paste it here. So I write comma, then quotes, and it's here. And now the next column is the horsepower, which is this one. So I add it here. And okay, that's the horsepower. And now the last column is fuel capacity, which is this one. So that's the last column we're going to choose, and with that we're done. So this is the last column. Now I'm gonna arrange this one here. So I press enter so you can see much better all the columns, and we have 7 columns in total. And now I'm gonna override the values of this data frame. So I write df underscore cars equal to this. So now it's there, and we can even make this much better so you can see, and now it's ready. So now we have this df underscore cars data frame, and now I run, and let's see how this data frame looks. So here I have the data frame, and we only have 7 columns now. And always is a good idea to select the columns you're going to work with, because sometimes the data frame has too many columns, and if you keep all the columns, it's hard to focus on the goal of your project. So it's a good idea to select all the columns you want before you start working, as I did. And now, before we finish this video, I'm going to show you the unique values inside all the columns we have. And to do that, I'm going to use a method we learned in this course, which is named and unique. So I write and unique, now parentheses, and this is going to help me see all the unique values inside the columns. So here I run, and now we see that all the unique values. And for example, the vehicle type has only 2 unique values as we've seen before, the passenger and the car type. And the manufacturer has 30 unique values, so probably 30 companies. And this is important because when we group values in a data frame, we have to make some operations in those groups. And if we have more unique values, that means that we're going to have more categories, so more groups. And the more groups we have, the more difficult to analyze it. Okay, that's it for this video. In this video, we reviewed this data frame and we got familiar with some columns that this data frame has. So now check this data frame on your own to help yourself understand much better the following videos. Alright, in this video, we're going to learn how the AGG method works, and also we're going to use some aggregate functions in this method. So we're going to start by calculating the sum of columns of this data frame that we had before. So in case you didn't watch the previous video, we created this df_cars data frame with cars information here, car sales information. So here we selected 7 columns, and now I'm going to use this data frame. So now I'm going to calculate the sum of columns, and to do that I only write the AGG method. So I write .agg and then open parentheses, and inside we have to write the function we want to apply to this data frame. So now I want to sum the values inside the column, so I write sum, and now I run this code and we see the result. And here in the first column that is called manufacturer, we got this weird result, and this is because this manufacturer column has text data, and since it's text data, here we concatenated the strings. So we didn't sum the values but concatenated the text, and we didn't want to do this, but we only wanted to sum the values. But for some reason the AGG method didn't completely understand what we want to do, and it concatenated the strings, but it doesn't matter. Let's check the next column, and this column has the sales in thousands, and here we got the sum of the values inside this column, and that's fine. So now the following column is the vehicle type, and here this one has text data, and this is why we concatenated the values here. But anyway, it's only text data that we can exclude later. And here the next column, we have the total sum, and also in the other columns. So now this is how you sum the values inside a column. And now I'm going to calculate the mean of numeric columns. So maybe we're going to get again the text data like we got here in the manufacturer column. So let's see. I'm going to write here the name of the data frame, which is df_cars, and now AGG and this parentheses. So now we write the function we want to apply to this data frame. In this case is the mean function, and here I run. And now there is a difference between these two functions, because here we got text data inside the manufacturer column and vehicle type, but here we didn't get it because here the mean also includes division, and probably division is not possible in text data, so this is why here it was omitted. So now we only got the columns with numeric data, for example the sales in thousands, and we see that the sales is greater than the price in thousands, and then we have the average engine size, which is 3, and then the horsepower and the average fuel capacity. Okay, now let's say that you want to apply not only the sum function or the mean function, but both. So you want to apply both functions to this data frame. In that case, we can add them to a list and then use the AGG method. So I'm going to do that here. We're going to calculate the mean and the count values. So here we're going to apply 2 functions. So first I write df_cars, then .apply, then parentheses, and now we open square brackets to indicate that we want to start a list. And inside we write the two functions that we want to apply. So in this case, I write mean, and the second is going to be count. So here I run, and we get 2 rows, and we get the 7 columns we selected before. And here we see that in the first row that has count as index, all the values had numeric data. And in the second row that has mean as index, we have some null data, because here we try to calculate the mean of text data, for example, in the manufacturer column, and that's not possible. So that's why we got this NaN that stands for null value, and well, we didn't calculate that data. If you want, you can modify and type any other function. So for example, the sum function instead of the count. So here I write sum, and now we get these values, and here we concatenate strings again. And anyway, you can include any function you want. Okay, now let's apply different aggregations per column. So we're gonna calculate the mean and also the sum of the columns sales in thousands, and also calculate the sum and max of the price in thousands column. So here I'm gonna write the name of the data frame, and I write df_cars, then AGG and parentheses. So now this has to be in a shape of a dictionary. So here we're going to use the lists again, but now to indicate the column that we want to work with, we have to open a dictionary and write it as a key. So for example, here I open quotes, and now I have to write the name of the column I want to work with. So in this case, it's going to be the sales underscore in thousands column, which is here. So I don't have it, so I'm gonna print it here, df_cars, so I can copy and paste it. So I choose this sales in thousands, so I copy this one, and now I paste it. So this is my first key. Now I have to write colon, and here the value. So the value is gonna be in list format, because we want to apply multiple functions. And now I'm gonna delete this, and here I'm gonna write the functions that we want to apply. So in this case, for the sales in thousands, we apply this first sum function. You know, I add it, and then the mean. So sum and mean. So there it is. And now we add the second pair of key and values. So comma, enter, and now we write the second pair. So here the key is gonna be the second column, so price in thousands. And now I paste it here, and here we have to specify the aggregate functions we want to apply to this column. So here I have the square brackets that indicates this is a list, and now I write the first function, which is sum, and the second one is gonna be max. So here I paste this one, then comma, and here max. Okay, now this is done, and what we're doing here is to apply the sum and mean functions to this sales in thousands column, and then to apply this sum and max function to this price in thousands column. So we're applying different aggregation functions per column. So now I run, and now we see the results. So here we see 3 rows, and we see also null values, because here we don't have a mean for the price in thousands. So you see here that we only have sum and max. And for example, here for the sales in thousand, we don't have the max function. So we only have sum and mean. But the 2 columns have one common function, which is the sum. And here we have values for both of them. And that's how you apply different aggregation functions to a column. Now let's see how to aggregate over the columns. So we're gonna make operations along the columns. So here I'm gonna sum 2 columns, and in this case I'm gonna select these 2 columns first. So I write df_cars, and now let's select, because if we don't select these 2 columns, the aggregation function we're gonna apply is gonna be applied to all the columns, and we don't want that. We only want to be applied in 2 columns. So here I select those 2 columns, and the first one is going to be sales in thousands, and the second one is going to be price in thousands. So I copy and paste it, And now, well, we have these two columns, and now I'm going to apply the AGG method. And here I write the name of the function I want to apply, which is the sum function. And this indicates that I want to sum the sales in 1000 column and also the price in 1000 column. So I want to sum these two columns. And now to specify that I want to make an operation along the columns, I have to add the axis parameter. So I write axis. In here, I write 1, which means columns. And now I'm gonna run this one and see the results. So here we see that we have a series and there are 156 rows, actually 157 because here the 0 counts. And now this is the same number of rows that the original data frame has. So I'm going to show you here. I print the df_cars and here we see 157. This means that we sum the values inside these columns. So we sum each row inside these two columns. And now you might be wondering why I didn't select each column and sum the two columns as we did in previous videos. So I'm going to show you what I'm talking about. So to sum these two columns, we could do this. So df_cars and then select one column and then write this plus operator and then write the other column. So this price in 1000 and this. So if we do this and I run, we get the same result. Here I did this because I wanted to show you how to aggregate over the columns using the AGG method. But also there is another reason why I did this, is because both approaches behave differently. So here in the first approach, you see that we have a value, a numeric value in the index 2. And here in the same row, we have a null value. And this is kind of weird because we should have the same result, but we have a different result. So I'm going to show you the data frame here and explain you what's going on. So here in index 2, we see that we have a numeric data for the sales in 1000 column, but for the price in 1000 column, we have a null value here. So NaN. So here in our first approach, here with the AGG method, this AGG method takes this null value as if it was 0. So here we got 14 and here this NaN is like 0. So we sum these two values and we got 14, of course. But the second approach, so summing these two columns, making the selection, is different. So the way it behaves is that if one value is null, the sum of two values is going to be null too, even if one value has numeric data. So that's how both behave and you have to keep that in mind. Okay, before we finish this video, I'm going to show you how to aggregate different functions and rename the index of the resulting data frame. So here I'm going to write again the df_cars data frame and here AGG. So I'm going to use this method and now here we have to use a different format compared to those we've used so far. And in this case, we have to use tuples, which are represented with the parentheses. So here, the first element is going to be the name of the column, and the second element is going to be the aggregate function. And outside the tuple, we write the name of the index that we want to set. So here, I'm going to show you. First, I open the tuple, and now I write the name of the column. So here, I'm going to choose the sales in 1000. So I just copy this one and I paste it here. So this is my first element. And now I add the function I want to apply. So in this case, the sum function. And now outside this tuple, I'm going to set it equal to the name of the index I want to set. So in this case, I'm not going to get this sum function as index, but I'm going to get the name I set here. So for example, if I want to set it equal to x, I'm going to get the x in the index. So here, I'm going to show you an example. Here, instead of getting the sum, the mean, and the max in the index, I'm going to get the name I set in the AGG method. In this case, the x name, which I'm setting here. So this one, I'm going to get this x name. And now I'm going to apply another aggregate function in the price in thousands column. So here I'll just copy this, add a comma, and here I paste it. So in this case, it's going to be a Y, a value or name. And here I'm going to write the price in thousand, which is here. So I copy. Now I paste it. And I'm going to use the same function. So you see how it works. So here I run this and we get this little data frame. And here in the name of the indexes, we get X, this one, and Y, so this one. So we rename the name of the indexes in this data frame. Here you can see that we have null values in the price in thousand and also in the sales in thousand. And it looks kind of weird because here we know that the sales in thousand is 8,320 for X and Y because X and Y represent the sum function, so it should be the same. But here, for some reason, it doesn't recognize that X and Y belong to the same function. So now you might think this is not so useful, but in the following videos, I'm going to show you how this is going to work with the group by method. This gets more relevant when we use both the group by method and the AGG method. And that's it. In this video, we learn how the AGG method works in pandas, and also we'll learn how to use some aggregate functions. Alright, in this video, we're going to learn how the split apply combine strategy works. And this strategy helps us group values in a data frame. So we build categories and we can apply some aggregate function so we see the values of those categories. So let's start with the split, and here let's split the data into separate groups. So here we're going to work with the vehicle type column, and let's see the values that this column has. So I think we've seen this in the previous video, but in case you forgot, here let's see the values. So I write vehicle underscore type, and now I'm going to use the value underscore counts method to see all the values inside this one. So we see that the vehicle underscore type has two values, and the first one is the passenger and the second one is the car. So here we can split that data frame into these two categories. So the first category is going to be the passenger category. So here we make a filter, and here I write df underscore cars, then open square brackets, and then I write the name of the column. So this one. And now I'm going to write a condition. So this equal to, and here passenger. So I copy and paste this. So now here, this is my condition, and I'm going to assign this equal to the passenger underscore, let's call it filter. So this is my variable. Now I'm going to do the same, but now for the car type. So instead of passenger underscore filter, I'm going to name it car underscore filter. And now here, this remains the same. And now this condition should be equal to car. So this is what we get. And now I'm going to comment this out. And now I assign these two conditions to the variables. So now I run, and here we have these two variables. I'm going to show you one of them. So here I have car underscore filter, and here we see that we got Boolean values in this series, and we're going to use that in the next step. So now I delete, and now the next step is the apply. And here we apply an operation, or we apply an aggregate function. So we get the value of the category that will show in a data frame later. But here we make that calculation. So here I'm going to filter the data frame based on these conditions. So here I write df underscore cars, then open square brackets, and inside we write the condition. So here is the passenger underscore filter first. And now I'm going to show you how it looks. So this is the filter that we made. So here we see that we only got the vehicle type equal to passenger. So if we go to vehicle type, we see that all of them are passenger. And now I'm going to choose a column to make the aggregate function. So here I'm going to choose the sales in thousands column. So this one. So now I select this, And here we get only this column. And now I have to choose an aggregate function. And in this case, I'm going to choose the mean. So I write that mean, and then I open parentheses. And now I calculate the mean of this column. So if I run this, we see the mean of the sales in thousands, but only for the passenger filter. And here I'm going to assign this to a variable. So I'm going to name it car, or actually passenger, because this is the passenger filter, passenger underscore, let's say average. So this is my first variable. And now let's create the second one. So here I write df underscore cars, then open these square brackets. And now I select this car underscore filter. So I paste it here. And now I'm going to choose the same column because we have to make the operation in the same column. So it's this one. And now I paste it here. And the operation is going to be the mean. So mean in parentheses. And now I'm going to assign this to a variable. And in this case, it's going to be named car underscore average. And here I forgot to add the quotes. So here we have the quotes. And now this is ready. So here I run this code and we got this. And now the last step of this strategy is combine. So we're going to combine the values of the apply step and the split step, and we're going to make a data frame. So here to make a data frame, I'm going to use that data frame method. So pd.data frame. And now I open parentheses, and to create a data frame, I'm going to use a dictionary. So I open these curly braces. Now I write the name of the key. And in this case, the name of the key is going to be the type we selected. So vehicle type. So I'm going to name this first column as vehicle underscore type. And then I open square brackets. And here we write the types of vehicles. So the first one is car. And the second one is passenger. So here, passenger. And now we add a second pair of key value. So here is going to be the sales in thousand. Then I write colon. And now I open these square brackets. And inside we write these two variables that we created here. So the passenger underscore average. And also the car underscore average. So I'm going to set it in the same order we put it here. So first car and second passenger. So here, first car and second passenger. So now this is ready. And what we're showing in this data frame is the categories here, the categories that we selected for these groups. So car and passengers. And also we're showing the values of the aggregate function that we're applying to those categories. So in this case, the average function. So now I press Ctrl Enter, and now we see the results. And here we see the vehicle type. So here the car type has 80.62 in average in sales, and the passenger has 43.23 in average in the sales in thousands column. And that's how you group values in a pandas data frame, and also that's how you apply some aggregate functions. And I know these are too many steps, but fortunately there is an easier way to do this with less lines of code, and is by using the group by method. And with that, we're gonna do this with one line of code and faster. So I'm gonna show you how the group by method works in the following video. Alright, in this video, we're gonna learn how the group by method works. And the group by method allows us group data into categories, and then we can apply some aggregate functions. So we see the values there. So for example, the sum, the average, or we can count the values inside each category. So we're going to start by grouping vehicle type and then calculate the mean. And this is the same we did before here in the previous video, using the split, apply, combine strategy. In this case, we used a lot of lines of code, but in this case, we're going to use an easy approach with the group by method, and we're going to group this category vehicle underscore type, and then we're going to compare the results. So here, let's start by writing the name of the data frame, which is df underscore cars, then dot group by, and then here I write the name of the column. So I'm going to use the vehicle type, so this one. Now I paste it here, and now I apply the aggregate function. In this case, we want to calculate the mean, so we write that mean, then parentheses, and that's everything we need to do. So let's review the syntax. First, the name of the data frame, followed by the group by method, and inside we write the name of the column in which we want to make the groups, and then we apply the function, and that's everything we have to do. Now we run this, and here we got this data frame, and here we see two categories. So in the vehicle type there are two categories. The first is car and the second is passenger. We only see columns that have numeric data, so here we calculated the mean or the average of each column, and now we can compare the result of this data frame with this little data frame that we got here using the split apply combine strategy. So here we only calculated the sales in thousands, so let's compare only that column. So here I have this data frame, and if we compare the columns, we see that the value in car is 80.62, and here is the same, and for passenger is 43.23, and yeah, it's the same in the sales in thousands column. So here we did the same thing, but now we use the group by method, and as you can see, this is a shorter method because we didn't need to split, apply, and combine, but we could avoid those steps and only do all of that with the group by method. And here there is a little difference. Here we have the vehicle type in the index, but here we have the vehicle type in the column. So we can set this as index if you want here. So set index, and then we set this vehicle type as index. So both are the same now. Or you can here add a parameter as underscore index, and here set it to false. So with this, the vehicle underscore type index will be a column. So now I run this, and here we see that this vehicle underscore type isn't an index anymore, but now is a column. And that's how the group by method works. Now I'm going to show you a different example so we can understand much better this method. So now let's group by manufacturer. So I write df underscore cars dot group by, and then inside parentheses I write this name of the column. So here I paste it, and now let's run this without applying an aggregate function like in the first example. So let's see what happens. So here I only group by manufacturer, and we got these words that says that this is a data frame group by object. So here when we use the group by method, we get a group by object. So this is the result of running this code. This actually is not the final result that we're going to use, but we can use this object to get to other values we want. For example, we can get the name of the groups of this group by object, but first I'm going to set this variable. So I'm going to name it group by underscore obj, so object. So now I run this, and now this variable has this group by object. Now I'm going to show you this object. So I print this, and here is the same object, and now I'm going to get to the groups attribute. So we have to write the name of this object followed by that, and here groups. So this groups attribute allows us to get all the categories that are inside this group by object. So here I run, and this has the form of a dictionary because we see here the curly braces, and now we have all the elements. So here in the keys of this dictionary we have the categories or the names of the groups, and in the values we have the indexes. So for example, the category Audi has these indexes 4, 5, and 6. So this means that the 4, 5, and 6 index has this Audi category, and only those rows. Other rows have other category. So now this is the groups, but now since this is a dictionary, we can get the name of the groups. So here I can use the keys method, and with that we get only the keys of this dictionary. So here I run. Now we only got the keys of the dictionary, so only the name of the manufacturers. So here there is Audi, Ford, Volvo, and so on. Okay, now let's use the get group method to get a specific group within the manufacturer column. So here I'm gonna reuse this object, so I copy and paste. And now I'm gonna use the get underscore group method. So I write get underscore group, now parentheses, and here inside we have to write the name of the manufacturer we want to select. So in this case, let's say I want Ford, so I write Ford. Now I paste it here. Now I run, and here we got the selection of Ford in the manufacturer column. So all the values inside manufacturer are Ford. So here we see only Ford. And if you check here the groups attribute, we'll see that the indexes are the same. So let me see here. I print now, and now let's look the word Ford. So it must be here. So it's BMW, and here is Ford. So we see 46, 47 until 56. And these are the same indexes we get here. So from 46 to 56. So this is the selection that corresponds to the Ford category. Okay, that's enough for the group by object. And now let's apply some aggregate functions. So now I'm gonna here use the name of the data frame. So I write df underscore cars. And now I'm gonna group by the manufacturer. So group by, here parentheses, now the name of the column here. So I paste it, and now I'm gonna apply the mean function. So here the mean method, sorry, here's the mean method, and now I run this, and here we get the data frame grouped by the names of the manufacturer, and here we have all the columns with numeric data. So we calculated for each group in the manufacturer column. Here we could set this index as column, as I showed you before, but this is enough. So now let's see the next example, and here we have to group by manufacturer and then calculate the sum. So this is similar, so you can try yourself, and I'm gonna do it now. So here I write df underscore cars, then group by, now parentheses, and now the name of the column. So here again, this manufacturer, which previously was a column, so I paste it here. Now we have to write the function we want to apply, so that sum, parentheses, and this is enough. So I run, and now we got a similar result that we got with the average, but in this case we grouped by manufacturer and then we sum the values inside each category. Okay, finally let's see these three last examples, and all of them involve the count function. So in this case we're gonna group by vehicle type and then count the values. So we write again the name of the data frame, so df underscore cars, then we group by vehicle type, so I write group by, then quotes, and then we write this column, so it's here. And now I'm going to count the values inside this column, so we use the count method, and now we run, and here we have only two categories because as we've seen before, this vehicle type, there are only the car type and also the passenger type. And here we counted the values inside each column. So for example, there are 41 values that correspond to the manufacturer inside the car type. And we see that we got the same number of elements for sales in thousands, but for the price in thousands and engine size, we got 40. So there is one element less. And this happens because some columns have some null values. So if a column has a null value, we won't count it because they aren't actually values, but they are NaN. If we want to count those NaN values, we could fill those null values with a number or with a text, and only in that case we will count those values. But as long as they are NaN, we won't count those values with a count method. So keep that in mind. Now let's verify which columns have these null values, and we can do that by using the isNull method and the sum method. So here I write df underscore cars, then isNull parentheses, and then we sum here all the null values. So here we see that only the price in thousands, the engine size, the horsepower, and the fuel capacity have null values. And this makes sense because those columns have less values than the manufacturer and sales in thousands columns. And here we see that those columns, manufacturer and sales in thousands, don't have any null values. So these results make sense. But what if you want to group by and then count the values, but then show the null values? Well, if you want to do that, you only have to add the drop NA parameter inside the group by method. And I'm going to show you how to do that in this last example. So in this case, we're going to group by engine size. So here I write df underscore cars, then group by, now parentheses, and now we write the name of the column. So here is the engine size, and now I add a new parameter. So drop NA, and we set it equal to false. So this drop NA parameter controls if we want to drop the null values or not. So if this is set equal to true, this means that we want to drop the null values, and we're not going to count it if we apply the count method, as we're gonna do in this example. So if we drop the null values, they are not gonna be counted. But if we set this equal to false, so drop NA equal to false, we're going to consider and include these null values in the group that we're gonna make. And then we're gonna be able to count these null values. So let's have a look at how it works. So now I run this, and here we see the result. So we see that there are many engine size types. So we have many groups, so 1, 1.5, 1.6, and so on. And if we scroll all the way down, we will see that the last row is the NaN. So here we have the null values. And here we see the columns that have null values. And this drop NA parameter might come in handy whenever you want to consider the null values in whatever operation you want to perform in the groups you created. And that's it. In this video, we learned how the group by method works in pandas. Okay, in the previous videos, we learned how the group by and the AGG method works. And in this video, we're gonna use both of them to perform more complex operations. Okay, now in this first example, we're gonna find the minimum and maximum value on each column. So here, first, we're gonna group by vehicle type, and to do that, we write first the name of the data frame, so df underscore cars, and then we group by the vehicle type. So here parentheses, and now the name of the data frame, which is vehicle, and then underscore type. And in the previous videos, we learned that if we want to get the minimum or maximum value, we have to use the min method. So let's try it out. So let's say we want the minimum value, so we use that min method, and here I run this, and we get the minimum value of each column. And if we want the maximum value, we only have to modify this and write max. So here I write max, and we get the maximum value. That's a common approach to get the minimum and maximum value, but now I'm going to show you how to calculate both of them at the same time using the AGG method. So here, instead of using the max method, I write AGG, and now here inside I open square brackets, so we create a list, and here we have to write all the functions that we want to apply to this group. So now I write min inside quotes and now max. So max, and now this is ready. So if I run this, we get the minimum and maximum value of all the columns. And here we can add as many aggregate functions we want. And also we can customize the name of the columns, and also we can apply different functions to many columns. And I'm going to show you how to do this in the next example. So here we're going to find the minimum engine size and the maximum horsepower. And to do that, first we group by vehicle type. So I copy and paste this one. And after this, we use the AGG method. But now, instead of writing the minimum and maximum functions inside square brackets, we'll use tuples this time. And to create tuples, we have to write parentheses. And here, the first element is going to be engine size. So here I copy this column name and now I paste it. And after this, I write the function I want to apply. So in this case, I want to find a minimum value, and here I write min. And now I'm going to set the name of this column that we're going to create here, and let's call it min underscore engine underscore size. So this name that I'm creating here is supposed to be instead of this column name. So instead of getting this default column name, we're going to get this customized column name. So now let's create a second tuple. So here I open parentheses, and now the first element is going to be this column horsepower. And in this case, I want to calculate the max function. So here I write max, and now here equal to, and now I assign the name for this tuple, and is max underscore horsepower. And this is ready. So let's review this syntax one more time. So first we group, as we've done so many times in this course, we group by vehicle type. And after this, we use the AGG method. And this AGG method has a different syntax. And here we use tuples. And inside these tuples, we have to write first the name of the column in which we want to perform an aggregate function. And then the second element is the aggregate function we want to perform. So here engine size and min. And then we have to assign a name for this column. And in this case, we assign these two names. And that's everything you have to do. Once this is ready, we can run this. And here are the results. So here we got the vehicle type in the index because we grouped by vehicle type. And then we have here two columns. So first is the min underscore engine size, and this is because here we set this name. And this column has the minimum value, so 2 and 1. And if we check the previous data frame we created here, we can verify that those values belong to this engine size column. So it's this min. So here we have 2 and 1, and 2 corresponds to car and 1 to passenger. So it's the same. Here we have min engine size instead of engine size, and here is the minimum value. So the minimum for car and the minimum for passenger. And the same goes for horsepower. So here we calculated this time the maximum value. So here the minimum and here the maximum. And we can verify that those values are correct because here in horsepower, here we have max, and for car it says 300, and for passenger it says 450, and these are the same values. So what we did here is to perform some specific aggregate functions to a particular column. So the minimum for the engine size and the maximum for the horsepower. So this is much better instead of just applying the aggregate functions to all the columns. So here we can focus only on the columns we want, and also set customized column names. Okay, now to understand all the concepts we learned, let's solve this example. And this time we have to calculate the sum of sales in thousands and the mean of price in thousands. So it's basically something similar to the previous example, but now new columns and also new aggregate functions. So here I'm gonna group first by the manufacturer. I didn't write here, but we have to group by the manufacturer this time. So I copy this, and now instead of writing vehicle type, I write manufacturer. So here, to write it correctly, I'm gonna use the columns attribute. So here I write cars, then columns, and now I run this, and now I copy manufacturer just to make sure I write it correctly. So I paste it here, and now I use the AGG method. So that AGG parentheses, and then we create the tuples. So the first tuple will be this one with the sales in thousands column. So we paste it, and here the aggregate function we want to perform is the sum. So now we set the name for this first tuple, and is sum underscore sales, then comma, enter, and here we create our second tuple. This time the column is price in thousands, so here price in thousands, and the aggregate function is the mean, so mean. Now we create the column, and here is mean underscore price, so this is the name of the column, now equal to, and now this is ready. So we have here the group object, and then here is the AGG method, and here the syntax that you already know. And now I'm gonna run this to see the result, and here we have a data frame, and in this data frame we grouped the data by manufacturer, and then we summed the values in the sales column, and then we calculated the mean in the price column. So here we have all the values for all the manufacturers. Okay, now I want to show you what's under the hood. So now we're gonna do the same thing we got in this data frame, but without using the AGG method. So only with the group by and an aggregate function. So you understand much better what we're doing now. So here we're gonna calculate the sales in thousand, the sum, so the first column, and only with the group by method. So here I copy, I paste it here, and now we sum the values in these groups. So we use the sum method, and now we select one column. So here first I'm gonna run, and I'm gonna show you here, if we sum, we get the sum of all the columns and for all these manufacturers. But now we only want one column, so we only want this sales. So here I copy and paste this one. So here I paste it, and now I run this, and let's compare the results of any value here. So let's take Audi. In this case, the value is 40. And now let's check here the sum sales. So for Audi is 40. So this is the same, but here we didn't use the AGG method, but only the sum aggregate function, and also we select only the sales in thousands, and basically this is the same. Here we just use the aggregate function, but without the AGG method. So now I'm going to show you the second column, how to do it. So instead of using AGG for mean price, we can do the same here. So I'm going to copy and paste because it's absolutely the same. So here, instead of using the sum method, we only write mean. And now instead of sales in thousands, we have to use the price in thousands. So now I paste this, and now I comment this out, I run, and let's check now BMW. So this is 33, and let's check here BMW and 33. So now it's correct. And I did this because I wanted to show you what's under the hood. So you can achieve all of this without using the AGG method, but you should use this AGG method to simplify things. But it's always good to know what's behind this shortcut. So here I showed you, and now you know how to do it with this group by and also how to do it with the AGG method. And that's it. In this video, we learn how to use the group by and AGG method together. Okay, so far we learned how to apply a built-in arrogate function to our group by object. But in this video, we're going to learn how to apply our own function using the lambda function. So here we have an example of the built-in function. For example, here is a sum function. So here we're grouping by manufacturer and then summing the values inside these groups. So this is what we learned so far. So here we have all the values and we have the sum in each column. Okay, this is what we learned so far. We have here the group by object, and now here we apply a built-in arrogate function. And here we got the sum of the manufacturers and in these columns. So here now we can apply our own function. And now to make an example, let's say we don't want to get the sales in thousands, but now we want to show the real value here. So instead of 79 for this value, we show 79,000. So all of them will be in the real value. So to do that, we have to multiply each value by 1000. And we can do that by using the lambda function. And I'm going to show you how to do it here. So first, I'm going to minimize this. And now I'm going to show you how the lambda function works in case you don't remember or you didn't check the previous videos. So basically, to create a lambda function, we only write lambda and then we have to write the input. So here we write any random variable. So I write x. This is my input and now the output. So let's say we want to output x plus 1. Now I assign a name for this function. So I write here sum 1. So here now if we apply this function, we write here sum underscore 1 and then we write any value we want. So let's write 1 and here we should get 2 because 1 plus 1 is 2. So now we run and here we got 2. So this lambda function is a one-liner function that we can create. And this is like a short version of the traditional function that we learned in the Python crash course. And the lambda function is preferred when we want to apply a customized function to a pandas data frame. So now that I explained you this, I delete this. And now I'm going to do what I told you before. So here we're going to calculate the values in thousands. So I'm gonna multiply this by 1000 and here I start by writing the name of the data frame, so df underscore cars, and then we group by the manufacturers. So here I copy manufacturer and then I paste it. So I have this group by object. Now we sum the values and after this we use the apply method. So apply. And inside parentheses, we write the lambda function. So lambda, my input is x and my output is x times 1000. So this is input and output. Now, if I run this, we get the real values of this data. So for example, this one is 79,000 and it's not 79 anymore. So here, this sales column is not in thousands anymore, but it's only sales because now we're showing the real data of this column. And now you can see that all the columns were multiplied by 1000, but not all of them have this in thousands in their columns. So we are only interested in these two first columns. So now let's select only these two first columns with double square brackets. And now I write the name of these columns. So here price in thousands. And now sales in thousands. So we only want to show those two columns because those are the actual columns that are in thousands. And that's how you create a lambda function and apply it to a group by object. Okay, now to understand this much better, let's see another example. This time we're going to subtract values from the mean of each group. So we're going to group again by manufacturer. And now we're going to create a lambda function that helps us subtract the values from the mean. So here I paste this group by object And now I write dot apply. So dot apply, and inside the lambda function. So now the input, so an x variable, and now x, which represents an element of my data frame, and now minus x dot min. So here with parentheses, and before I do this, I'm going to show you the data frame again, so you can see what the x and the x min represents in this data frame. So the x represents a value inside this data frame. For example, this 16, this 39, or this 14. But the x dot min represents the average values that are in these groups. So here we're grouped by manufacturer. So we get here Acura, Audi, BMW. So here we calculate the mean of each value. So here, for example, Acura, the mean is, I don't know, 10. And after we do that, we subtract 16 minus 10. So we have to select the right average for each manufacturer. And then we subtract each value from the mean of each manufacturer. So here we're not calculating the mean of the whole column, but we're calculating the mean of each group. Okay, now that this is clear, I delete this and now I run. And here we have this result. So for example, in the engine size column, we got the first value, which is -1. And this indicates that this value is under the mean. So this is less than the mean of the engine size. But here we have 0.27, and this indicates that this value is over the mean. And as you can see, this function that we created shows us the values that are under the mean and over the mean, so we can recognize which are good values. Okay, before finishing this video, I want to show you what's under the hood of this lambda function. So here I print the data frame df underscore cars, and well, we have these values. This is the original data frame, and now I'm gonna calculate the mean of the category manufacturer. So we're gonna group by manufacturer and then calculate the mean. So I'm gonna do that just to show you what's under the hood of this lambda function we created. So here I write df underscore cars, and then we group by the manufacturer. So here I copy and paste this, and after this I'm gonna calculate the mean. So here we have the groups by manufacturer, and then we calculate the mean. So now we have these values, and now let's make this operation. So let's subtract x minus x dot mean. So this x first means the value inside this data frame. So for example, 16. And this x dot mean is the average in each group. So for this example, 16, the average is the average of Acura. So here, let's check the average for this first example. So Acura, the average is 19. And if we subtract 16 minus 19, we get a value close to -3. So now let's verify. So here in this data frame that we got after applying this lambda function, we see that in the sales in thousands column, in the first row, we have this -2.83, which is close to -3. And well, this is great. So we verified that this is correct. So we only subtract these values from the mean. And now let's check one more example. So here, let's pick Audi. In this case, it's 20.39. And now let's check the average of Audi. So in the sales in thousands columns. So here, Audi is 13.5, and 20 minus 13 is 7. So now let's verify in this data frame. So we check here the row with the index 4, and now index 4, and now we look for the sales in thousands. So here is 6.87, and this value is close to 7. So this is correct. And with this, I wanted to show you that arrogant function like the mean, when they are applied inside the lambda function, we apply this mean to the groups that we get after using the group by method. In this case, the group by method grouped by manufacturer. So we calculate the mean over the manufacturer groups. And that's it. In this video, we learned how the lambda function works, and we created more complex functions using the apply method and the lambda function. Okay, in this video, we're going to learn how to filter values based on an aggregate function. And to do that, first we have to create a group by object. So here, let's create the group by object. So I write df underscore cars, then the group by method. So I write group by, then parentheses, and here I write the name of the column. And now I'm going to get the name of the columns by using the columns method. So I write it correctly. So manufacturer, I'm going to do this example with the manufacturer column. And now I use the filter method. So the filter method helps us filter values based on an aggregate function when we use it with this group by method. So here we only have to write filter and then open parentheses. So now inside this parentheses, we have to specify a function, and we can create our own function and specify the condition that we want to set for this filter. So let's do this. So I'm going to create a function using this def keyword, and the name of my function is going to be filter underscore func. Then I set the parameter x, then colon, and we're going to return this condition. So first x, and now we select a column. So this x parameter represents a data frame, and if we open these square brackets, we're selecting a column. So here I want to select the column sales in thousands. So I'm going to create a condition based on the sales in thousands column. So I paste this, and here we're going to compare the sum in the sales of these manufacturer groups. And to do that, we write the sum method, and now we compare this with a value which is going to be the mean of the sales in thousand. And to calculate the mean, here I'm gonna use the mean method. So here I run this, and now we see that the mean of the sales in thousands is 52. So this is the mean of the whole column. So now I use 52, and now this filter function is gonna filter groups based on the sum of the sales in thousands. So this has to be greater than 52. So if we have a manufacturer with a total sales less than 52, that company or manufacturer is going to be filtered out. So now what we have to do is to copy the name of the function and put it inside parentheses. So here in my filter method, we specify that we want to apply that function. So in this function, we have this condition, and we're going to filter based on that condition. So now I'm going to set a name for this data frame, because what we get here is a data frame with this filter. So only the values that pass this filter are going to be in this new data frame. And I'm going to set this data frame name. So I write df underscore filter, and now this is my new data frame. So here I'm going to show you this data frame, and now everything is ready. We have the function, we have the group by object, and we use here the filter method. So that's everything we need. So now I show you this new data frame, and it's here. So I scroll down, and all the values here passed this filter. So all the manufacturers passed these filters. So that means that the sum of the sales is greater than 52. So Acura passed, Volvo passed, and so on. Okay, great. Now I'm going to show you which manufacturers were filtered out. And to do that, I'm going to use the same group by object. So here I copy this, and now I paste it. So this is my group by object. And now to calculate which manufacturers were filtered out, I'm going to use the sum aggregate function, and now I run this. So here we get the sum of these values, and we get the columns, and we grouped by manufacturer. So here I'm going to select only the sales in thousands, because this is the column we use in this function. So here I select only this column, and here we have this column. And now I'm going to sort the values ascending. So I write sort underscore values and parentheses. So we use this method, and here we get the values of this sum in the sales column, and now is ascending. And here we see that the first 6 manufacturers have total sales less than 52. So here, to see it much better, I'm gonna use head and then 6. So only we see that 6 first values. So here, Porsche, Jaguar, Saab, Infiniti, Audi, and BMW were filtered out. Okay, now let's see how many values these 6 manufacturers had in the original data frame. And to do that, I'm going to use the is-in method. So here, I'm gonna use the same column. So here I write manufacturer. So I copy this and now I paste it. And after this, I use the is-in method. So now parentheses, and inside I write the name of these 6 manufacturers. Okay, I pasted the 6 manufacturers, and now I'm gonna filter this data frame. So I copy the name of the data frame, and now I add these square brackets. So now I run this to see this data frame. Okay, now this data frame only contains cars that belong to these 6 manufacturers. So we see Audi, BMW, and so on. Now let's see the shape of this data frame by using the shape attribute. So here I write that shape, and now I run, and we see that the shape of this data frame is 13,7. The first is the number of rows, and the second is the number of columns. Great, now let's compare the shape of the original data frame and the shape of the df_filter data frame to see how many rows we lost in the filter. So here I write df_cars, and now the shape attribute, and here we see that in the original data frame we had 157 rows. And now let's find out how many rows we have in the filter data frame. So this one, I copy this, and now let's paste it here. Now I use the print function to print both values, and it's here. So I run, and we see that in the original data frame we had 157 rows, but in the filter data frame we have 144. So here we lost 13 values or 13 rows, and those 13 rows belong to these 6 manufacturers because those manufacturers didn't pass this filter that we created in the function. So those have total sales less than 52. So they didn't pass this filter, and that's why we removed these 13 rows from these 6 manufacturers. And that's it. In this video, we learned how to use the filter method with the group by object. In this video, we're going to see the dataset that we're going to work with in this section. And first, we're going to import pandas as PD. So here I run this first line of code. And now I'm going to read 2 datasets that we're going to work with in this section. The first is a movies dataset from IMDb, and the second is the ratings of those movies. So let's read the first CSV file. So I write pd.read_CSV, then parentheses, and here I write the name of the CSV file. So IMDb and movies.csv. So now I read, and now let's see what happens. So here we got a warning message, and we also got the data frame. This warning message is recommending us to use this low_memory parameter and set it equal to false. So this is some kind of issue. So I'm gonna set this low_memory equal to false. And now if I run this, we'll see that we get the data frame, but now we don't get the warning message. So this is an issue that we have with this dataset, but if you add the low_memory parameter, everything will be fine. So now we have the first data frame, and now let's see some columns that we're going to use for the section. So here, this data frame has a lot of columns, Actually, if we scroll all the way down, we can see here that it has 22 columns, and we're not going to use all of them, but we're going to use only 5 of them. And now let's see those 5 columns that we're going to work with in this section. And the first is the ID. So this IMDb underscore title underscore ID. This one contains the IDs of columns, and IDs are unique. This means that we won't find duplicated IDs, but they are unique. So each movie has an ID. Okay, the next column that we're gonna use is the title column. So this is the name of the movie. And then we're gonna use the year column. So this is the year in which the movie was published. And also we're gonna use the genre, and finally the country. So those are the 5 columns that we're gonna use in this section. And I'm gonna set this data frame equal to df underscore movies. So now I run this, and here we save the CSV file into this data frame, df underscore movies. So now let's check the second CSV file. So this one is about ratings of those movies, and I'm gonna read this CSV file with the read underscore CSV method. So I write read underscore CSV, then here I write the name. So IMDb, then rating.csv, and here is ratings. So now it's ready. I comment this out and run this. So here now we have the data frame, and each column measures the vote in different ways. So for example, here we have the total votes, here we have the mean and the median, and so on. So we have a lot of columns here, but we're going to use only the IDs. This ID column is the same ID column that we found in this df underscore movies data frame. And the next column we're going to use is the total underscore votes. And finally, the last column that we're going to use is the mean underscore vote. So this is the mean of the votes for each movie. And now I'll give a name to this data frame. So I'm going to write df underscore ratings. So this is the name of this data frame. And now I run this. Okay, now let's select the columns that we're gonna work with in this section. So I write first df underscore movies dot columns to get all the columns. And now to overwrite the data frame, I'm gonna write df underscore movies equal to df underscore movies, but now with double square brackets. And inside I write the columns that we're gonna select. So these are the columns I mentioned before, and I just pasted these 5 columns. So the ID, the title, the year, the genre, and the country. Now let's do the same with the df underscore ratings. So now I overwrite the data frame, and now I select the 3 columns that I mentioned before. To do so, I change the name of the data frame here. So I write df underscore ratings dot columns, and now we get all the names of the columns. Now I'm going to select just the columns that I mentioned before. Okay, I pasted the 3 columns, and now everything is ready. So I run this code, and now let's see how the data frames look. So here I run the df underscore movies, and now we only have 5 columns. And now I copy and paste df underscore ratings, and we only have 3 columns. And as you can see, both data frames have 1 column in common, and this is the ID column. Keep that in mind because we're going to use that column a lot in this section. And that's it. In this video, we explored the 2 data frames that we're going to work with in this section. Now is your time to explore more these data sets so you can understand much better what we're going to learn in this section. Alright, in this video, I'm going to show you how to concatenate data frames in pandas. In pandas, we can use the concat method to concatenate 2 data frames. And there are 2 different ways to concatenate data frames. We can concatenate data frames vertically and horizontally. And in this video, I'm going to show you how to concatenate data frames vertically. So first, let's see these 2 data frames that we're going to use as examples. And here we have the data frame df1 and df2. And these 2 data frames have 2 columns in common. So those two columns in common are the ID and the age. In the first data frame, we see that the values inside the ID column start with the letter A and ends with the letter D, while in the second data frame, the values for the ID column starts with the letter E and ends with the letter H. So we have different values. Whenever we want to concatenate two data frames vertically, we need to have columns in common. In this case, the columns in common are the ID and the age columns. And by concatenating, we will have a data frame that combines the data inside the df1 and df2. Okay, to indicate in pandas that we want to concatenate two data frames vertically, we have to write the axis parameter and set it equal to 0. 0 means vertical concatenation. And if you go to the pandas documentation, you will see that this is known also as concatenating along the rows. So that's another way to call this concatenation. And now let's see how to concatenate these two data frames. So here, if you want to concatenate vertically, you have to imagine that one data frame is over the other. This helps us visualize the final output of our data frame. So if we put df1 over df2, this is like concatenating df1 and df2 vertically. So here, let's see the result of this. So if we concatenate these two data frames, we're going to get this final data frame, which has this ID and age column and has all the data in both the df1 and the df2. So here we see that in the ID column, we have data from A to D that corresponds to df1 and also data from E to H that corresponds to df2. And well, all the data inside the H column was concatenated too. Another thing you have to keep in mind is that by default, pandas will concatenate the name of the indexes even if they have the same values. So in data frame 1, we have indexes from 0 to 3, and in data frame 2, we also had indexes from 0 to 3. So this means that the output data frame will have repetitive indexes, and this is not a good practice. Later, I'm going to show you how to deal with this kind of behavior, but now let's see the code that helps us concatenate vertically. So here is the code, and we have to write PD. This PD comes from pandas, and then we have to write the concat method. So we write dot concat with parentheses, and inside parentheses we write a list, and we start this list with square brackets, and as elements we write the two data frames. So first data frame 1, df1, and then df2. So here we can add also the axis parameter and set this equal to 0 because we want to make a vertical concatenation, but it's not necessary because the axis is set to 0 by default in the concat method, and we can omit that parameter. Alright, enough talking, and now it's time to start writing code. So let's go to Jupyter Notebook, and here I have the code that creates the df1 and df2. So I'm gonna run this code, and now I have df1, which is this one, is the same data frame I showed you before, and also df2. So now let's use the pd concat method to concatenate these two data frames. So here I write pd.concat, then we open parentheses, and here we open square brackets. So first we have to write the df1 and then the df2. So here we can omit the axis parameter, but in this case I'm gonna add it. So axis equal to 0. So this axis equal to 0 indicates that we want to concatenate vertically. Okay, now I run this and we see the result. So this is the output, and we see that we have the same data frame I showed you before in the slides. So here we have the ID and the age column with the data of df1 and df2. So now I'm going to show you some other parameters you can add, And first is the ignore index. So if you check here, you can see that there is the ignore index. This helps us ignore the original indexes from the df1 and df2. So if we add this one, so ignore underscore index and set it equal to true, we'll see that here we get 0, 1, 2, 3, 4 until 7. And we see that we don't get the 0, 1, 2, 3 indexes twice because we ignored the original indexes. So this new data frame will have a new index, ignoring the indexes from df1 and df2. And that's how you use the concat method in pandas. Now we're going to see an exercise, and we'll use this data frame that I showed you in the previous videos, and we're going to use this IMDb movies dataset and also this IMDb ratings dataset. So in the previous videos, we read these two datasets and we assigned the df underscore movies and the df underscore ratings values. And in this video, we're going to use these two datasets or data frames to solve an exercise. Remember that we also selected some columns, so we focused only on these 5 columns in the df underscore movies and these 3 columns in the df underscore ratings. Okay, in this exercise, first we have to extract a 50% sample of the original data frame. And this data frame is the df underscore movies that I showed you before, so this one. So we have to use the sample method to extract a 50% sample. Then we have to show the shape of the data frame that we created here. So after extracting a 50% sample, we create a df underscore sample data frame, and here we check the shape of that data frame. And then we concatenate the df underscore movies and df underscore sample data frames. In this case, we concatenate vertically. And that's what you have to do. So now try this yourself, and after you try to solve this exercise, you can continue watching this video to see my solution. Okay, to solve this exercise, we're going to start by extracting a 50% sample, and we do that with the sample method. So we write df underscore movies dot sample. So this sample method we learned previously in this course, and as you might know, this sample method has a parameter named frac, and that helps us get a percentage of the original data frame, in this case the df underscore movies. So we set this frac equal to 0.5, and this means 50%. Then we only run this, and here we have the data frame. So this is the sample, and here we see that the number of rows is 42,000. So this is half of the number of rows in the df underscore movies. And now I'm going to set this data frame equal to df underscore sample. So now I run, and I just created this df underscore sample. Now let's see the shape of this data frame. So I write that shape. This is a shape attribute. And now let's check, and we see that it has 42,000 rows and 5 columns. Now let's see also the shape of the df underscore movies data frame. So here I copy and paste, and now instead of df sample, I write df underscore movies. So now I print, so we can see both values together, and now I run. So we see that, yeah, we have half of the number of rows of the df underscore movies. And also we have the same number of columns. And actually these are the same columns because we extracted a sample. So if you check here, df underscore movies has these 5 columns: title, year, genre, country, and also the df underscore sample has the same columns. And this is important because, as you might remember, when we want to concatenate vertically, we need to have columns in common. So these two data frames have columns in common, and that's why we can concatenate them vertically. So don't forget about that. And now let's concatenate these two data frames. So here I write pd.concat. Now we open parentheses. Now I create a list with square brackets, and now I write the name of the first data frame, which is df_movies. And now I write the name of the second data frame, df_sample. Now we want to concatenate vertically, so I add access equal to 0. And remember that we can omit this access parameter if we want, because the access parameter is set to 0 by default. So now everything is ready, so we can run this, and here we have the data frame that is the output of this concatenation. So this is the result, and now we can verify that we successfully perform this concatenation by getting the shape of this data frame. So here I'm going to assign a name to this data frame. I'm going to name it df_concat_vertically. So it's here, and now I only run this, and now let's check the shape of this data frame. So here I write the name of the data frame followed by the shape attribute. And now we have 128,000 rows, and this is the sum of 85,000 rows plus 42,000 rows. So this is the sum of the rows in data frame 1 and data frame 2. So with this, we can verify that we successfully concatenated these two data frames, because by concatenating vertically, we sum the number of rows of the two data frames and the number of columns remain the same. And that's it. In this video, we learned how to concatenate vertically in pandas. Alright, in this video, I'm going to show you how to concatenate data frames horizontally. And we're going to use the concat method as we did in the previous video. So first, we're going to see these two data frames. And here, the second data frame, df2, it's different from the previous example. So in this case, this df2 has only one column, and this column is named job. And this column is different from the columns that df1 has. So here in the job column, we have the professions of people in data frame 1. So we can say that this data corresponds to the same data we have in data frame 1, but they are split. So as you can see, we have different columns, but the indexes are the same. So both have the indexes 0, 1, 2, and 3. And this is a requirement to make a horizontal concatenation. So here we need to have the same indexes to concatenate horizontally. And in pandas, when you use the concat method, you need to specify that the access is equal to 1. This access parameter equal to 1 indicates that we want to concatenate horizontally. And if you check the pandas documentation, you will see the sentence along the columns, which means concatenating horizontally. So it's the same. Okay, now we'll see how we can concatenate these two data frames. So basically, we need to put one data frame next to the other data frame. So we have df1 on the left and df2 on the right. So now, if we concatenate these two data frames horizontally, we're going to get a data frame that has 3 columns. So the 2 columns of df1 and the 1 column of df2, and also 4 rows. So the 4 rows that are in those 2 data frames. So let's see the output of this concatenation. So if we concatenate horizontally, we're going to get this data frame. So the 3 columns and the 4 rows. And we could concatenate this because we have these indexes 0, 1, 2, and 3 in common. So now you see that we have the job information available in one data frame, and also the ID and the age column. So now let's check the code that will help us create this data frame. So if we want to concatenate horizontally, we have to write pd.concat, and inside write the 2 data frames inside square brackets, because this is a list. And then we have to specify axis equal to 1. And that means that we want to concatenate horizontally. So by default, axis is equal to 0, which means concatenate vertically, but when we set it to 1, we tell pandas that we want to concatenate horizontally. And that's everything you need to do. All right, enough talk. Now let's write code in Jupyter Notebook. So now I go to Jupyter Notebook, and now I have the code that creates the data frame df1 and df2. So I run this code, and now I show you the data frames, which look exactly the same as the two data frames we've seen before, so df1 and df2. So now let's concatenate these two data frames. So I write pd.concat, then parentheses, then we need to write the two data frames inside a list. That's important, don't forget about it. So first df1, then df2, and now we have to specify the access. So access equal to 1. So this means concatenate horizontally. Now I run this and we get a single data frame with the 3 columns. So we see the ID, the age, and the job in this single data frame. Okay, now let's check some other parameters that might come in handy. So here you see the ignore index. In this case, we don't need the ignore index because we make a concatenation that is horizontal and we have the same indexes. Actually, that's the reason why we can make this horizontal concatenation. So it's not useful for this case. And now a parameter that might come in handy is the sort parameter. So this sort parameter allows us to sort the data frame. So if you set it equal to true, you will be able to sort this data frame. And that's it. Okay, now it's time to put everything we learned into practice solving an exercise. So here we're going to use the datasets that we read previously. So these are the IMDb movies dataset and also the IMDb ratings dataset. So in previous videos, we read these two datasets and we set it in these two data frames. So here we have the df_movies and the df_ratings data frames. We're going to use these two data frames for this exercise. And remember that we selected these 5 columns for the df_movies and these 3 columns for the df_ratings data frame. Okay, now in this exercise, your task is first to show the shape of the data frames that will concatenate, so the df_movies and the df_ratings. Then you have to concatenate these two data frames on the IMDb title_ID column. So this is the column that these two data frames have in common. And you have to concatenate these two data frames horizontally. So after you concatenate these two data frames horizontally, you set a name to the concatenation, and then you use the shape attribute to calculate the shape of this new data frame. So now is your time to solve this exercise on your own, and after you try, you can continue watching this video to see my solution. Okay, let's start solving this exercise. So first, we calculate the shape of the two data frames. So first I write df_movies, then that shape, and this returns the number of rows and the number of columns of this data frame. So now I'm gonna get the shape of the df_ratings too. So here, instead of writing df_movies, I write df_ratings. So now I print both shapes, so I use the print function, and now I run the cell, and here we have the output. So we see that we have the exact number of rows in these two data frames, but the number of columns is different. So in the first data frame we have 5 columns, and in the second data frame we only have 3 columns. All right, now let's continue, and now let's concatenate the two data frames. So we use pd.concat parentheses, then we open these square brackets, which is really important not to forget, and here we write the first data frame. So I copy and paste it, and then I copy and paste the second data frame, so df_ratings. Then we have to specify the access equal to 1 because this is a horizontal concatenation. And now everything is perfect, but we need to make a little change. So as I mentioned before in the theory, we need to have common indexes. And in this case, we have a common column, which is the ID column. And we can set this column as an index. So we have a common index between these two data frames. So let me show you here. So here, if I print that df_movies, we see that we have this ID column in this data frame. And now if I print the df_ratings, we'll see the same column in this data frame. So here is the data frame and we see the same column. So this is the only column that these two data frames have in common. And we can use this column as an index. So if I use the set_index, we can set this column as an index. So here I write the name of the column and now I run this. And as you can see, now this ID column is my new index. And we can do the same for the df_movies data frame. So here I comment this out and now I set that column as an index. And now to update the data, we have to use the inPlace parameter and set it equal to true. So this helps us save all the changes that we made with the set_index method. So we do the same for the second line of code. So here I write inPlace equal to true. And now with this, we're going to set the ID column as index for both columns. So now I run. And if we check any data frame, we'll see that the index is the ID column. So perfect. Okay, and only now we can concatenate these two data frames because right now the index of df_ratings is the same index that we have in df_movies. So this is the requirement that we need to concatenate horizontally. So we satisfy that requirement and now we can run this code. So I run this code and now we have this concatenation. So this data frame has the 4 columns of the df_movies and the 2 columns of the df_ratings. And here the index is the ID column. So perfect. Now I'm going to set a name to this data frame, which is going to be here df_concat_horizontally. So this is the name of my data frame. And now let's check the shape of this data frame. So I write the name of the data frame followed by the shape attribute. So now we see that this data frame has 85,000 rows. So this is the same number of rows that the df_movie and df_ratings had. So that's fine because when we concatenate horizontally, we don't change the number of rows. Actually, the number of rows have to be the same because we should have indexes in common. But now in the columns, we see that this df_concat_horizontally has 6 columns, but the df_movies has 5 columns and the df_ratings has 3 columns. So here we see that by concatenating these two data frames, we get the sum of these 2 columns. And now you might be wondering, 5 plus 3 is 8. So this is not equal to 6. But here we set the ID column as index in both data frames. So we lost 1 column in each data frame. So this is why here we have 4 columns and here we have 2 columns. So now 4 plus 2 is 6. And with this, we can verify that we successfully concatenated these 2 data frames. And that's it. In this video, we learned how to concatenate 2 data frames horizontally. Alright, in this video, we're going to see how joins work in pandas. And first, we're going to see the inner join. The inner join returns matching values between 2 tables. In this case, it will be the matching data between 2 data frames. So if we have data frame 1 on the left and data frame 2 on the right, the data that we have in common is the data that will be in the middle. So the area with the white dots that you see in this image. So now let's check how the df1 and df2 look, and these are the data frames that we'll use in this example. So df1 and df2 have a column in common. In this case is the ID column, and also df1 has the age column and df2 has the job column. But what is important here is that the ID column has some values in common between df1 and df2. So if you compare these two columns, you can see that the C and D values are the same between these two columns, while this A and B only belongs to df1 and the E and F only belongs to df2. So if we keep that in mind and we see again the diagram that we've seen before, we can see that the A and B is on the left, while the C and D is on the area with the white dots, while the E and the F is on the right. So this represents the data inside the ID column in these two data frames. So this is basically how the inner join works. So the data that only belongs to df1 will go to the left, and the data that is in common will go in the middle, and the data that only belongs to df2 will be on the right. Okay, now this inner join is possible because we have the ID column in common between these two data frames. So this allows us to make this inner join. And to write the code that produces this inner join, we have to use the merge method. So we write df1, which is the data frame on the left, and then we use the merge method. So that merge, and then inside parentheses, the first parameter is the second data frame, so df2. Then we have to write the on parameter, and here we have to specify the column that both data frames have. So in this case, the ID column. And finally, we have to specify the how parameter. And here we write the type of join we want to perform. In this case, inner join. So we write inner. And when we make this inner join by writing this code and using this merge method, we get this data frame. So the output is this data frame that you see now on screen. And this data frame has the three columns. So the age belongs to the df1 and the job belongs to df2. And we only see two rows. We see the row that has the data C in the column ID, and also the second row that has the data D. So this is the output after using the merge method. Now let's write some code in Jupyter Notebook. So let's go to Jupyter Notebook, and now I have these two data frames. I have the code to create these two data frames, and now I just run this code, and now I can show you these two data frames. So I write df1, and you can see the first data frame, and df2, and you can see the second data frame. So now let's use the merge method to merge these two data frames. So we write df1.merge, then parentheses, and inside df2, then on, this is the on parameter, and here we write the column that these two data frames have in common. In this case, the ID, then the how parameter, in this case inner, because we want to make an inner join, and that's enough. That's everything we need. So now we run this, and we get the same output I showed you in the slides. So these three columns and this data that corresponds to the C and D ID. Okay, now let's verify the shapes of these three data frames. So I'm gonna assign this data frame a name. So I write df_inner_join. So this is my data frame. And now let's check the shape. So first df1.shape. Now I copy this. I paste it twice. df2, df_inner_join. So now I paste it. And now I'm gonna print the three values. So here I use the print function, and now it's ready. So now I run this code, and we see that the first two data frames have the same number of rows and columns, but the last data frame, so the data frame that represents the inner join, has only 2 rows and 3 columns. So this happens because these 2 data frames have 2 rows in common. So here we see these 2 rows that have in common, which are in the C and D rows. So these 2 rows, and here the 3 columns are the ID, the job, and also the age column, which is here. So this is why we have 3 columns and 2 rows. And that's how you make an inner join using the merge method. So now let's see an exercise to put everything we learned so far into practice. So for the exercise, we're going to use the df_movies and df_ratings data frames that we created in the previous videos. So now let's check the exercise, and it's here. So for the exercise, you have to merge the df_movies data frame and the df_ratings data frame. You have to explore the data frames and find the column that these 2 data frames have in common. And after that, you have to use the how parameter and set it equal to inner to make this inner join. So now you can try this yourself, and after that, you can continue watching this video to see my solution. Okay, to solve this exercise, first let's see the 2 data frames so we can find a common column. So here is the df_movies. We see these 5 columns, and now let's print the df_ratings, and let's see what column they have in common. So I just realized that the 2 data frames have this ID column in common. And now I only have to use the merge method, open parentheses, and write this df_ratings inside parentheses. Then in the on parameter, we can write the name of this column, which is imdb_title_id. And then we have to write the how parameter and set it equal to inner. But here there is a little detail you have to know. So here the default value that the how parameter has is inner. So if you press Shift plus Tab, you can see here in this little window here in how the default is inner. So you can use this to find the default values that all the parameters have. And in this case, the how parameter has this inner value by default. So this means that we can omit this how parameter because it's set to inner by default. So I can delete this, and now I can run, and we can see that this data frame have the columns of df movies. So these 4 columns belong to df_movies, and these last 2 columns belong to this df_ratings. And also the IDs that df_movies and df_ratings have in common are shown in this data frame. So only the common IDs are here in this data frame. And that's how you make an inner join between the df_movies and df_ratings. Now I want to show you a different way to use the merge method. So this way is similar to the way we use in concatenation, but now is in merge. So the only thing you have to do is to write pd.merge, then parentheses, and write the data frames you want to merge. So df_movies and df_ratings. So this looks like the syntax of the pd concat, but now instead of pd concat is pd merge. Now we have to add the on parameter and set it equal to the ID column. So now I set equal to this, I comment this out, and if I run this, we get the same result. And well, the IDs that these 2 data frames have in common are in this ID column. And that's it. In this video, we learned how to make an inner join in pandas. Alright, in this video, I'm going to show you how full joins work. And full joins allows us to join all the elements between 2 tables. And you can see much better how full join works in this diagram. So here, all the white dots cover all the space in these 2 tables. So all the area covered by the white dots represent the full join in this diagram. And now let's see an example to understand this much better. So here I have the 2 data frames we've used in the previous video, And what we're gonna do here is to join these two data frames, but in this case with a full join. So here, now we have all the elements from the ID column. So here is the ID column of df1 and ID column of df2. So we can see that here C and D are the elements in common in this column. So A and B only belong to df1 and E and F only belong to df2. But we see that all the elements are taken by this full join, because this full join takes all the elements in these two data frames. And we can see here that we have df1 and df2 again, and we see that A, B, C, D, E, and F are covered in this full join. So now let's see how to write code that produces a full join. So here again, we have to find a column in common. In this case, the column that both data frames have is the ID column. And to make this full join, we have to use the merge method. So we write df1.merge, and inside parentheses, we write df2, and then on the on parameter, we set it equal to the column that these two data frames have in common. So in this case, the ID column. And finally, in the how parameter, we set it equal to outer, because this is a full join, also known as an outer join, and well, they are the same. So the outer join is the same as the full join, or full outer join. Anyway, so now let's see the output of this full join. So what data frame we're gonna get after using this code? So the output will be this. So this data frame has all the data that we had in df1 and df2. But as you can see in this data frame, only the rows that belong to the IDC and IDD have non-null values, while the rest have some null values. And this happens because the df1 doesn't have the job column, and the df2 doesn't have the age column. So this produces some null values when we make this full join. But this is fine. This is just how the full join behaves when we have this type of data frames. So now enough talk. Now let's see how to produce this full join using pandas. So let's go to Jupyter Notebook, and now I'm going to show you the two data frames we're going to work with, which are the same data frames we've seen in the slide. So first the df1 and then the df2. So here's df1 and df2. So for a gentle introduction to this full join, we're going to merge these two data frames, and now we only have to write here df1 dot merge, then parentheses, here df2, then on, and here the ID, because this is the column in common. Then how, and we set the how parameter equal to outer. And now this produces the data frame we wanted, and here we see that the A and B ID have null values, and the E and F have null values too, while the C and D don't have null values because these are the elements in common between these two data frames. Okay, this is how the full join works, and now to understand much better all the concepts we learned so far, we're gonna solve an exercise, and in this exercise you have to merge two data frames. In this case, the data frames df_movies and df_ratings. These two data frames we've seen in the previous videos, and now you have to find the column in common and perform an outer join. So now try to solve this exercise on your own, and after you do that, you can continue watching this video to see my solution. Okay, to solve this exercise, let's explore this df_movies and df_ratings data frame. So here I print this df_movies, and now we have this data frame that we've seen in the previous videos. So now let's find which column they have in common. So here I print df_ratings, and as we can see, both data frames have this ID column. So I'm going to use this in the on parameter, and here I'm going to use the merge method first. So that merge, then open parentheses, then we write the second data frame, and now we write the on parameter. So on equal to this IMDb underscore title underscore ID. So now how in the parameter we set it equal to outer. So now this is ready. So we run this and we get this data frame that is the full join of the df underscore movies and the df underscore ratings. So as you can see, these 4 columns belong to these df underscore movies, and these 2 last columns belong to the df underscore ratings. And this full join looks like the horizontal concatenation we learned in previous videos, and that's an alternative to solve this type of exercise too. But in this case, I chose to use the merge method because we're learning full joins, but you could also solve this exercise with the concat method. Okay, that's enough for full joins. And now we're gonna see a type of join that is similar to the full join, but has some differences. Okay, now it's time to see exclusive full joins. And exclusive full joins will pick only the values that are exclusive to the tables. So here I have 2 tables, and the exclusive values from table 1 and exclusive values from table 2 will be taken in this exclusive full join. So only this area that you see here on the left that is exclusive to the first table or first data frame, and also this area that is with the white dots that is on the right that is exclusive to the second table or second data frame. So this is known as the exclusive area because it belongs either to one table or to the other table. However, the area that is in the middle is the common area, and this area is not considered in this exclusive full join because this area belongs to both tables or both data frames. Okay, now let's see an example. So we're going to use the same data frames here that we've been using so far. And now let's see how these elements will fit in this diagram. So now we see that the A, B, E, and F were taken in this exclusive full join because here in the data frame, we can see that A and B only belong to df1 and E and F only belong to df2. However, C and D belong to both df1 and df2. So this is why we didn't take this C and D, because this is exclusive full join and we only want exclusive values. So now let's see how we can make this exclusive full join with code. First, we need, of course, a column in common. So in this case, the column in common is the ID column. And after we find this column, we need to use the merge method. So we write df.merge, and inside we write df2 and then also the on and the how parameter. In this case, the how parameter is going to be outer, so it's similar to the outer join, also known as full join. But in this case, we're going to add an extra parameter, which is the indicator. So this indicator helps us know which values are exclusive to df1 and which values are exclusive to df2. So after we add this indicator, we're going to get a new column in our output data frame, and this new column is going to be named underscore merge by default. And in this column, you will see values like left only, right only, and both. So the values that are left only corresponds only to the data frame on the left, in this case df1, and the values that say right only corresponds only to the data frame on the right, which is df2. And these are the 2 values that are exclusive to df1 and df2. So once we have this column, we're going to use the query method to select only the exclusive values to df1 and exclusive values to df2. And with this, we're going to filter out the values that these 2 data frames have in common. All right, now let's see the data frame that we're going to get as output after running this merge method. And the output is going to be this. So we only get the A, B, E, and F IDs, and the C and D were filtered out. Also, you see that we have some null values because the df1 doesn't have the job column and the df2 doesn't have the age column. And this is why you see here some null values. All right, now let's see how to make this exclusive full join using pandas. So now I go to Jupyter Notebook, and again, I'm going to use the df1 and df2 that we've seen before. So these are the same data frames we've seen in the slides and also in the previous videos. And I'm gonna use these two data frames to make this exclusive full join. So here, what I'm gonna write is first df1 merge, and here df2. Then also we add the on parameter equal to id and the how parameter equal to outer. So this creates a full join, and that's fine. But now we want an exclusive full join. So we have to add the indicator equal to true. And here I copy and paste the code, and now I add the indicator equal to true. So with this, we create a new column called underscore merge, which is this one. And as I mentioned before, we have here three types of elements: left only, both, and right only. So left only are the elements that are exclusive to df1, and right only are the elements exclusive to df2. But the both values are the elements that have in common df1 and df2. Great. Now let's get only the left only and right only values from this merge column. And now I'm going to use the query method. So here I copy and paste. And now I'm going to use this query method. So I write that query. And after this, I'm going to write this query. So here I press enter so you can see much better the query I'm about to write. So to select only the left underscore only and right underscore only values, we first open these quotes and now write the name of the column. So in this case, underscore merge. And now we compare with this equal sign, so double equal sign, and now we write left only. And now we have to do the same with the right only, so I copy this and I paste it here. But now instead of left only, I copy and paste right only. So now we need to add the quotes to specify that this left only and right only are strings. So here I add quotes, and here I add quotes again. And keep in mind that here I'm using single quotes, but here in these quotes that we wrote before, here I wrote double quotes. And this is to avoid some type of conflict between quotes. And now I'm gonna use the or operator. So we indicate that we want either left only or right only. So here I write or, and this is how we select the left only and right only values from the merge column. So here I'm gonna run this code. So I press Control Enter, and now you see that this data frame that we have as output only shows the values that are left underscore only and right underscore only. And that's everything you have to do to make an exclusive full join. All right, now that you have a good idea of how to make these exclusive full joins, we're gonna solve an exercise. So here in this exercise, we have to merge df underscore movies and df underscore ratings. And in this case, the type of join is going to be an exclusive full join. And well, now explore df underscore movies and df underscore ratings. Those are the data frames we've seen in the previous videos. So you have to find the column in common and then use the same steps we followed here. So first add the indicator, then add the query, and then make this exclusive full join. So now try to solve this exercise on your own. And after you do that, you can continue watching this video to see my solution. Okay, to solve this exercise, first let's have a look at the data frames. We've seen these data frames before, so I have a good idea of the column that they have in common, but in case you don't remember, I'm gonna print both data frames. So first the df underscore movies, now the df underscore ratings. So as you can see, both data frames have this ID column. And now we're gonna use this column to do this exclusive full join. So now I write dot merge, then parentheses, and now I put this second data frame inside parentheses. Then I add the own parameter, and in this case it's gonna be equal to this IMDb underscore title underscore ID. And then we add the how parameter. So here equal to outer. We press Control Enter, and with this we get this full join. So this is a full join, and what we want right now is an exclusive full join. So here I'm gonna add the indicator. So I copy and paste, and now I add the indicator parameter equal to true. So now to see much better this, I'm gonna press enter here, and now it's much clearer. So I'm gonna run this cell, and here we see the data frame, but now a new column was created, and it's this underscore merge column. And here we can see that most of the values are set to both. And now I remember that these two data frames, df underscore movies and df underscore ratings, have the same ID. So all the values inside the IMDb underscore title underscore ID column are the same. And that means that all the values inside the underscore merge column are going to be equal to both. So all these values will be both, and this will affect somehow this exclusive full join. But I'm going to show you what's going to happen. But first, let's add the query. So here, I'm going to minimize this data frame. Now I paste this code, and I'm going to add the query. So I write query, parentheses, and now I'm going to copy and paste the same query we created before, because it's the same query we're going to use every time we want to make an exclusive full join. So every time we want to make an exclusive full join, we only use this code. So here, this is ready, and now I press Control Enter, and we see that this data frame is empty, and we see only the column names, but there is no data in this data frame. And this happens because here in the underscore merge column, all the values were set to both. So this means that all the values in the ID column are the same between the df underscore movies and df underscore ratings. So these two data frames have the same IDs, and none of these data frames have exclusive IDs. So this is why we got this empty data frame, because these two data frames don't have exclusive values. And this is fine. We didn't make any mistake. This happened only because the IDs between these two data frames were the same, but this code that we wrote here is correct. And that's it for this video. I hope you successfully solved this exercise. Alright, in this video, we're gonna see how left join works. Left join allows us to grab only the data that belongs to a data frame or to one table. So this is the data that is exclusive to data frame 1 or table 1, and also the data that data frame 1 or table 1 has in common with data frame 2 or table 2. So both areas are covered by the white dots, and this represents the left join. So now let's see an example, and we're going to use the same data frame we've been using so far. So this df1 and df2, and now let's see how this data inside the ID column will fit into the diagram. So here we have this A, B, C, D, E, and F, and we see that only the data A, B, C, and D is covered by the white dots. And this happens because this data belongs to the df1. So here we see that in the ID column, there is the A, B, C, and D IDs. So this data belongs to df1, and the E and df weren't selected because these two IDs belong only to df2. So this is why these E and if IDs weren't selected in this left join. So the left join will return only the data that corresponds to the left table or left data frame. So in this case, the df1. All right, now let's see how to make this left join in pandas. And as usual, we will need a column in common. And in this case, the column in common is the ID column. So both the df1 and df2 have this ID column. And now what we have to do is to use the merge method to create this left join. So we write df1.merge, then parentheses, and then we write df2 because that's the second data frame. Then on the on parameter, we set it equal to the column in common, in this case ID. And after this, in the how parameter, we set it equal to left because we want to make a left join. Okay, after we do this, we're gonna get the following data frame. So this is the data frame that we get after making this left join. And as you can see here, all the data that belongs to the df1, that is the IDs A, B, C, and D, will be in this data frame. However, some data is missing. So we see here some null values, and this happens because the df1 doesn't have this job column. And this means that we don't get that data because that data doesn't exist. However, for the IDs C and D, we got the data that corresponds to the job column because this data also exists in the df2. And since we have that data, when we make the left join, we get this data that is doctor and a statistician. So this happens because we made a left join. And now that's enough for the theory. Now let's check how to make this left join, but now writing code in Python. So let's go to Jupyter Notebook, and here I'm going to use the same data frames, df1 and df2. And now let's make this merge. So I write df1 dot merge, and then I write parentheses and write df2 inside parentheses. So now df2, and now the on parameter will be equal to ID, and the how parameter will be equal to this left. So we set it equal to left because we want to make a left join. Now we press Ctrl Enter, and now we have this data frame. So here we have some null data, and here we have the data that corresponds to df2 in the job column, and also IDs A, B, C, and D are in this data frame because this data corresponds to df1. Alright, that's how you make a left join. And now let's put everything we learned into practice by solving this exercise. So in this exercise, we're going to use the df movies and df ratings data frames, and then we're going to follow these steps. First, we extract a 50% sample of the df movies data frame, and then we merge this sample. So here we give a name to this sample data frame. We assign the name df underscore movies underscore sample, and we merge this new data frame with the df underscore ratings. So here the type of join is going to be a left join. And once you have this data frame, you have to get the shape of all the data frames involved in this exercise. So we compare the shapes and draw some conclusions. All right, now it's your time to solve this exercise on your own. And after you try to solve this exercise, you can continue watching this video to see my solution. All right, to start solving this exercise, I'm going to extract a 50% sample of the df underscore movies data frame, and I'm going to use the sample method. So I write df underscore movies and then sample, and then I open parentheses. We learned this method in this course before, and now you might know that here we have the frac parameter, And this frac parameter allows us to extract a percentage or a fraction of the original data frame. So in this case, we want the 50%, so we set it equal to 0.5. And with this, we get this sample. Now I'm gonna give a name to this data frame, and the name is gonna be df_movies_sample. So we run this, and now we have this sample. So now let's merge the two data frames, and first let's write df_movies_sample that merge, then parentheses, then the second data frame, and now I write the on parameter. In this case, the column that they have in common is this ID, I guess. Let me check here. So this data frame has this ID, and also this ratings, I believe, has this ID. So let's check, and yeah, they have in common this ID column. So here I write the ID, and now as last parameter we add how, and now we set it equal to left because we want to make a left join. So now I run this, and this is the data frame we get after making this left join. So I'm gonna give it a name. In this case, this is gonna be equal to df_left. And now it's time to compare the shapes of these data frames. So here I write df_movies_sample. So I better copy and paste now that shape. So we get the shape of this data frame. And now I print this. So print, and now copy and paste this twice. So now I write df_ratings. I copy and paste it, and finally df_left. And after I get the shapes, we're gonna compare the values. So now I run this, and we have these shapes. So here the first element is the number of rows, and the second element is the number of columns. And we see that the number of rows of the df_movies_sample is around 42,000. The number of rows of the df_ratings is 85,000, and the number of rows of the data frame we got after making the left join is also 42,000, or around 42,000. And this happened because we made a left join, which means that only the data that belongs to this df_movies_sample will remain, and the data that is not here but is only in the df_ratings will be excluded. So we're using this ID column in this on operator, and this indicates that only the IDs that belong to the df_movies_sample will remain in this df_left. And that's why we got around 42,000 rows in the data frame that corresponds to the left join. That said, all the number of columns were combined. So here we have 4 columns of the first data frame, 2 columns of the second data frame, and then the ID column that these two data frames have in common. So in total, 4 plus 2 plus 1, so 7 columns in this final df_left data frame. And that's everything you need to know about left joins. And now let's see a different type of join. In this case, we're going to see the exclusive left join. And this is a bit similar to the left join, but now we're going to get exclusive values from the data frame that is on the left. So here, let's see the diagram. And now you see that the white dots only cover the area that is exclusive to the first table or first data frame. So here, let's see an example. So here we have the df1 and df2. And now let's see how the IDs fit into the diagram that we've seen before. So let's check it out. And it's here. So we see that only the A and B IDs are taken in this exclusive left join, because these are the only IDs that are exclusive to this df1. So here in the data frame, we see that this ID A and this ID B is the only data that is exclusive in this df1. in the ID column. So if you try to find this A and B ID in df2, you won't find them because it's exclusive of df1. And you see also that the rest of the IDs, so C, D, E, and F, isn't exclusive of df1. So this is why these 4 IDs were excluded in this exclusive left join. So now let's see how to make this exclusive left join with pandas. So first, as usual, we need a column in common. In this case, this column is the ID. And after we recognize this column, we have to use the merge method again. So we write df1.merge, and then we write the second data frame, in this case df2. Then we write the ID in the on parameter, and then in the how parameter, we have to set it equal to outer. And as a rule of thumb, we always set the outer value in the how parameter when we want to create an exclusive join. So either an exclusive left join or an exclusive full join or an exclusive right join. So every time we want to create an exclusive join, we have to use the outer in the how parameter. Okay, after this, we have to use the indicator parameter and set it equal to true. So as you might remember, this indicator will create a new column called underscore merge, and there we will see the data that is exclusive to df1, the data that is exclusive to df2, and also the data that belongs to both df1 and df2. After we get this column, we're going to use the query method to get the data that is exclusive to df1 only. So we're going to see in detail that when we write code in Jupyter Notebook, but now let's see the data frame that we're going to get as output. So this is the data frame that we get after making this exclusive left join. And as you can see here, the data that we get is only the data that corresponds to the A and B IDs. So here we see that in the job column, we got null values. And this is because the df1 doesn't have this job column. And as a result, we got these null values. So now, enough theory. Now let's write code in Jupyter Notebook. And now let's create this exclusive left join. So let's go to Jupyter Notebook. And now here, we're gonna merge these 2 data frames, df1 and df2. And to do that, we have to write df1.merge and then df2, then the on parameter equal to ID, and then the how parameter equal to outer. With this, we create a full join. So I'm just gonna show you here. But if we add the indicator parameter, we can set this indicator equal to true. So I just copy and paste this. Copy and paste. Okay, and with this indicator equal to true, we created this underscore merge column, and here we're gonna pick only the left underscore only values, because these values represent the values that are exclusive to df1. So left underscore only means the data that is exclusive to the data frame on the left. So in this case, df1. And we're going to exclude the both and the right only values because that data isn't exclusive of df1. So now let's create a query. So here I copy and now I paste it here. So now I write that query, now parentheses. Now I press here enter so you can see much better the query that I'm about to write. And here I open these quotes. Now underscore merge, because this is the name of the column. Then we write double equal sign, and now I write the left underscore only because this is the data exclusive to df1. So here I write single quotes and paste left underscore only. And with this, our exclusive left join is ready. So now I can run this and we can see the result. And we get this data frame, and on the merge column, we see that the data that we got has only the left underscore only values. So with this, we can verify that this exclusive left join was successfully performed. And that's everything you need to do to create an exclusive left join. And now we're gonna put everything we learned into practice by solving this exercise. So in this exercise, you have to follow these steps. First, you have to make a copy of the df_movies data frame that we've seen in previous videos. And then you have to set the first 1000 values of the ID column as this ID that I created. So this ID that I created is TT123456789 and 0. So this is a ID that I just came up with, and you have to set this ID to the first 1000 values of this ID column. After you do that, you have to merge the data frame that you got after making the copy, which I named df_movies_2, and you merge this data frame with the df_ratings. And the type of join that you're gonna make here is an exclusive left join. And after this, you have to find the shape of all the data frames that are involved in this exercise to compare and draw some conclusions. All right, now it's your time to solve this exercise. And after you try to solve this exercise, you can continue watching this video to see my solution. Okay, to solve this exercise, first I'm gonna make a copy of this df_movies data frame. So I write df_movies.copy. So I'm using the copy method we learned in this course. And then we set this equal to df_movies_2. So with this copy method, we make an independent copy. Now we run this, and now we created this df_movies_2. After this, to set the first 1000 values to this ID that I created, I'm gonna use a for loop. So here I write for index in, and here I'm gonna loop through the indexes in this data frame that I created. So here I write df_movies_2 and then that index, then colon, and then press enter. So here I'm gonna show you what I'm doing. So this index attribute returns all the indexes in this data frame. So here we're looping through these indexes. And now I'm gonna write a condition. So I write if index is less than 1000, then execute the following code. So with this, we're gonna change the values of the first 1000 rows only. So now I press enter, and here